welcome to Intellipaat. In this video, I'll be talking about Hyperledgers. Hyperledger is an umbrella project of open source blockchains and related tools. It started in December 2015 by the Linux in December 2015. It has also received contributions from IBM, Intel, SAP Ibria to support the collaborative development of blockchain-based distributed ledgers. Now, let us take a look at the agenda for this video. Firstly, I'll be introducing the Hyperledger Fabric, followed by origin of Hyperledger Fabric software, then blockchain for businesses, followed by working of Hyperledger, and then Hyperledger frameworks and tools, followed by membership and blockchain. And then later, why exactly do we need Docker? And then, what are the uses of Docker in Hyperledger Fabric? Followed by Chaincode and Hyperledger consensus algorithm. And then we'll be taking a look at some of the application programming interfaces. And then transaction endorsement, followed by installing pre-requested software for Hyperledger Fabric. And finally, we'll be taking a look at Hyperledger Fabric software setup and complete hands-on tutorial. And lastly, we'll be taking a look at quick overview of the AWS blockchain requirement. But before we begin with the first topic, please make sure that you subscribe to our YouTube channel and hit the bell icon for regular updates.
Okay, let's talk about building a Hyperledger Fabric solution. Okay, first I'll give a very high-level architecture diagram, and then we'll talk about it. Okay. So as you know about Ethereum is mainly designed or majorly used to develop application which will be used by anyone in the world. So that means you build a public applications, and then you have those applications deployed on the Ethereum main network, that is your production network, and anyone can actually download it and use it, right? That's a public blockchain. And the way that works is you have a Ethereum network. When I say network is nothing but many nodes participates in the network, right? So globally, there are so many people who are running their mining machines, and they join the network. And it need not be always a miners. It can be anyone who, if they just want to see what's happening in the Ethereum transaction, they can just participate in the network and see what's happening. But otherwise, there are miners who will mine the incoming request, and then they get paid as a reward and a fees, and the end-to-end transaction takes place, right? So that's on the public blockchain. And if you see the way the market is growing is there are so many applications people have developed on Ethereum public blockchain, and a lot of things are very successful products which runs on a public network. And the workflow is very simple. So you have your Ethereum network, and then you build a Solidity smart contract. You deploy the smart contract onto the network, and that gives you a contract address. And then you build an API or a front end, which will be using Web3.js library. You will be talking to your smart contract and then execute it. And you can build your front end with any languages, right? That's how things works. And what you also learned is you can even develop applications on Ethereum with a private network. Basically, when you develop a private network, you don't have this proof of work, right? That is your consensus algorithm or the mining mechanism. That won't be available. But then Ethereum is not designed to develop a private or a permission blockchain network. And the better approach is to go with the Hyperledger Fabric. So I'll just explain a very high level architecture of, if you were to develop Hyperledger Fabric application, what would be the architecture? Then we'll go a little deeper onto the subjects. So take a use case now. So when we talk about Hyperledger Fabric, this is basically we design for permissioned network. Unlike Ethereum, where anyone can join the network, in Hyperledger Fabric, we want only people having permission can join the network. Use case can be many. One use case, what we can talk about is the supply chain. So what happens here in the supply chain is, we can take any supply chain as an example. Let me take medical industry as a supply chain. So what happens here is, I am the end consumer who goes to hospital or a pharmacy and buy a medicine. Now, what I don't have a understanding is the medicine authentic? Okay, or the medicine they have produced it, have they followed all the standards? Or whatever the medicine I'm buying it, are these medicines, are they not expired? Are they not reused it? Right? I want to know all the information about a particular medicine. As a consumer, I want to know that. And let's say, sorry, go ahead. Okay, so let's say there's a particular medicine and which is actually causing a illness to the people because of there's something wrong with that particular drug or a tablet, right? And this hospital or the pharmacy, they want to know the truth behind that, where exactly things went wrong and who made that particular mistake. Now, in the current world, the way things happens here is there are so many, when we talk about supply chain, right? There are so many players in the industry. We'll talk about one by one. Now, usually in the real life supply chain, there will be n number of organizations participate. But in the diagram, I'm going to take few. So the first one will be who provides the raw material. It can be some chemical, it can be some whatever the materials are required to produce that particular product. And there can be many organizations. They will be supplying the raw materials to the producers. And the next in our supply chain, we have factory. Now here, this factory is the one actually produces that particular product. It can be anything. It can be your tablet, or it can be syringe, or it can be gloves, or it can be any other thing. If you compare this with the retail industry, it can be TV or Apple or any other product with producing. So what factory does? Factory needs to follow some set of standards to produce that particular product. And then in a supply chain, once the factory produced it, and then they will contact the shipment company, right, who needs to ship this particular product globally. And once these shipment companies, they ship this product, and it will go to the wholesaler on that particular region. Once it goes to the wholesaler, so wholesaler will be selling it to the multiple vendors. Okay, so in our case, we'll take one as an hospital as example. It can be hospital, pharmacy, and there can be many, yeah, hospital. And I'll also put another one like hospital two, or maybe pharmacy. I'll put it here, right? So this is how currently we are doing it. Now, what happens here is, now let's say this factory follows a particular standard to produce that material. So I'll just say produce. So what these guys do? Whatever the standards they follow, or whatever transactions they do, what they usually do is they insert into their database, right? This database can be of any type. This database can be even a simple Excel sheet also. Okay, so now these guys will be inserting data into their database, maybe your SQL Server or traditional databases. So similarly, what we also see here is, now shipment company will also have a database, and then similarly your wholesaler will also have a database, and hospitals may or may not, or pharmacy may or may not will have the database. Now, one more thing, what we also see here is the people who produce they may not even have any technology in place, and they might be using some paper or anything to make an entry. That's their ledger. That's their database. Now, what happens here is whatever transactions these guys are doing, or they will make an entry to this particular database. So, if you take one particular product here, let's take syringe for example. Okay, now these guys produced given a raw material to factories, and factories have produced syringe, and then that has given to the shipment company, and the shipment company has given to the wholesaler, and they've sold it to the hospital. They also sold it to the pharmacies here. Okay, now I'll tell you a scenario, and then you tell me what would be the problem here. Now we'll take one consumer here. So now consumer has bought this syringe, and he he finds that that particular syringe is actually not up to the standard. Maybe rusted, or let's say something wrong with that particular thing. Okay, and then he had used that, and because of that, he got some allergy or rashes or something. And then he sues the hospital because he bought it from hospital, and he files a case against the hospital, telling that I bought this, but this was not under the standard. Because of that, I got injured. And this happens. Uh, may not be so common in India, but in any other country, this is a common thing. So now this guy is going to sue hospital. Now, what I want you to think and answer me is leave the blockchain part for now. In non-blockchain part, this is how the things are, right? How can this hospital identify where the mistake was? Okay, so the problem is, so let me put it this thing, okay? So tracing an event, okay? So the problems, what you mentioned here is, so everything is manual, okay? Then obviously time taken, yeah? Going to take obviously a lot of time, yeah? Long time, okay? What else? Okay. See, now let's say that um, while we are investigating this, so we got to know that the factory is the one who is a culprit. Why? Because this guy has reused the product. When that particular syringe was expired, and these syringes must be dumped, or these syringes must be put in a garbage or whatever. They'll have some recycling process, right? But what factory has done is they've just took off the plastic cover on top of this, and then they've repacked it again, because in the inside you will not know whether it is still a valid or not. This can be same with you're buying a tablets, or you're buying some medicines, or you're buying some, let's say, Amrutanjan or Vicks or whatever it is, right? A box you can put any sticker, but the inside the box, whatever content you see, you can never identify whether that is expired one, or it is still valid one, right? So factory, we gets to know that the factory is the one is doing. Factories also realize that yes, we are the one made a mistake because we have made an entry to that. Now before this hospital finds out there's a mistake here, what factory could do here to to stop that, to stop blaming them? That's right. So what factory can do? Factory can tamper, right? Tamper, or modify the database, modify their data, right? So basically, you can call it as a fraud. Okay, now so there's a fraud happens, yeah. So now what we also see here is because these databases, whatever they maintain internally, right? First thing is, as I was about to say, that even in the investigation, these organizations doesn't want to give access to the parties, right? Unless until there's a government involved, unless until there is a police or verification involved, they will give an access. Otherwise, they will not even give an access. And the second problem is, even if they give access, they can modify the data because it is controlled by them, right? Now, this we call it as a centralized database. Yeah. What else? What are the other problems you see here in the non-blockchain solutions? Yeah, and the big challenge with the raw material is, at least these guys have some kind of database. It can be Excel or something, but here this is a big problem if they use like paper or something like that, right? Yeah, so paper and pen, I'll just put it like this. There's no way you can actually validate that. Okay. Apart from this, there are also other challenges that the shipment company sent a product to the wholesaler, and wholesaler needs to pay the shipment company, and the wholesaler, what they might try to do here is, or even the shipment here, any of the organization here, they have received the product, but they complain telling that the products are not up to the quality, and I will not be able to pay you the full amount. I'll pay you only 70% of that, whatever agreed upon. Now, because this is a global thing, what I'm talking is, I just walk into a one small pharmacy or hospital, buy something. But if you went to track that product, the product is not manufactured in India, not everything, right? It might be, if I'm taking this as an example, in India, I might be, but we are sourcing it from, let's say, any other country in the world, right? So that means from country to country, there is a transaction also so it's happening, right? The border payments and everything. So payment is also another issue. Okay, so this is some of the problems, what we face when we use um, non blockchain applications in the any supply chain industry. Now, let me ask you this question since you already know about blockchain. Now, I'm thinking Hyperledger Fabric will solve this problem. Can you guys tell me what can we do to solve these problems? Okay, no problem. I'll explain that. All right, okay. So now what we say here is when we talk about Hyperledger Fabric or to solve this problem, this can be solved by using a shared ledger. So I'm going to take the same example here, okay, or I'm going to on top of this only, okay. So what we wanted to do here is we want to implement Hyperledger Fabric to solve this problem so that we can trace any particular event or any particular event happened on the particular product. Now, the problem what we see here is everyone is having their own database, right? Instead of that, what we wanted to do here is we want to create one shared database. Okay. So now I'm going to call this as a shared database. Okay. So what we are thinking here is, okay, let's use a Hyperledger Fabric and that'll give a shared ledger. So now when I say shared ledger is, so now all these guys are come together and they will have a discussion telling that, what, these are the problems what we have. To solve this problem, let's use a Hyperledger Fabric. Now, for us to use a Hyperledger Fabric, there are a lot of things needs to be done. There is an investment that every organization should bear for that. When I say organization, all these are organizations. Okay, use this word organizations in Hyperledger Fabric. So there will be some cost involved, and we need to bear this particular cost. Then yes, okay, they all need to agree upon that. Yes, okay, we are ready to do that because we want to trace this particular thing. Sure. Now, what happens here is every organization here we see they need to set up particular network or in this entire whole thing that whatever I'm saying here, right? We're gonna build this blockchain application or Hyperledger Fabric solutions, and this entire thing I'm gonna call it as a network. Okay, so now we have our network here, and once we have our network, then what we are going to do, we will ask every participant or every organizations in the network to have what do you say that particular infrastructure ready with them. So take an example of the pharmacy here. Now what this pharmacy must do here is, I'm going to take this also for pharmacy here. Now for them to set up a particular network, so what they will have to do, they will have to have a host. They can host anywhere, okay? So they need to host a particular infrastructure. So I'm going to call this as an infrastructure here. Infrastructure. So when we say infrastructure, is basically, let's say they just need a virtual machines. That virtual machine should have a public address. So now they will have a virtual machines in that virtual machines, and we will be running our applications. And the way we run all this Hyperledger Fabric applications is basically your Docker containers. I'll talk about Docker container a little later once we go on to this implementation of database implementation. I'll talk about that. Okay, so that means there is a little cost involved in every organization. So this is not only the pharmacy. Every organization they'll have to put some money and then to have this basically the VM and then running the Hyperledger Fabric. And it's not going to cost too much, but yes, there is a cost involved, but not too much of cost. So likewise, what we want here is we want the hospital also to have a database, and similarly we want the other organization wholesaler to also have a particular database. Now in that case, what happened, so every organization will have the infrastructure ready with them. Okay, so now you can run this infrastructure on physical environment, or you can run this infrastructure on cloud or anywhere. but you need to have this particular infrastructure with you. Basically, the VM, on top of this VM, all the Hyperledger Fabric, Docker containers are running. Now, one more thing, what we are also going to do here is, now because we are now converting or changing the usage of from traditional database to Hyperledger Fabric, we will be running Hyperledger Fabric ledgers. So now inside our database, what we'll be running here, we'll go a little more detail on all of this. We'll be running multiple components of Hyperledger Fabric. So I'm going to call this as, like, there is a lot of peer networks and something is there. So I'll not talk about that for now. But one important thing is now we're going to have a ledger. Okay. Similarly, other organization as well. Now, what we say to solve this earlier problem. Now, we will tell all these organizations, you know what? We want to create one shared ledger, a shared database where whatever transactions or whatever inputs you do, you put it into a database which will be accessed by anyone in the organization. Okay, that's called as a shared ledger. So that means what happens, whatever data we have been seeing here, this can be accessed by everyone else. Okay, so I'm just going to put this kind of a line here just to identify. Now this are the shared ledger. So now what happens here is there is a ledger created, a database is created. Now the factories produce that particular syringe and they make an entry to that particular ledger. Now similarly, the shipment company, they ship the item to the wholesaler and they make an entry to that particular ledger. And similarly, wholesaler makes an entry, hospital makes an entry, pharmacy makes an entry. So everyone makes an entry. Now, because these content are shared ledger, and also we are running it in the Hyperledger Fabric network, and then these contents are immutable. So whatever data goes and sits inside the Hyperledger Fabric ledger are immutable, same like your blockchain. So that means whenever any challenge happens or whenever any event happens, we can just go back to that particular item. Now, in this Hyperledger Fabric world, we use some terms. So one is we use a term called as assets. Okay, so whatever we say, these are the assets. Okay, and whatever assets we enter those detail inside this asset detail will be tracked in the entire supply chain. So that means we take a one syringe as an example. That syringe, we make an entry to our database, and that the syringe has been followed so and so standards. And now syringe has been given to the shipment. Shipment followed. This is the way of shipment standards they followed, and they've given it to the wholesaler. Wholesaler used this kind of material. This the local what do you say courier guys and things like that. Then they're given to hospital. So every detail will be added to that particular network. And any point of a time, if you want to know anything about that asset, you can trace it back. Now, how are you going to do? Maybe like use some QR code or use some unique RFID or something like that for every particular asset. But still, there are some challenges which Hyperledger Fabric cannot solve, which is outside of technology. Now, one example I'm saying is the syringe. Yes, we have put the RFID on top of the package of syringe, but not actually on top of the syringe, right? Or even if you take a Vicks as an example, right? Vicks cream inside the bottle, we don't know that can be reused, right? But on top of the bottle, there can be RFID, and you can scan that. You can identify the origin. You can identify where exactly the mistakes are. But inside that, you cannot solve anything. So that's why you see the adoption of Hyperledger Fabric for production. It is taking time because there are a lot of challenges which is outside of the technology. Okay, so now what we understood here is if you were to redesign this supply chain using the Hyperledger Fabric, now the things are not manual now. Now everything is resolved now. So now if I were to compare this now with Hyperledger Fabric now, so I'll put it like this. Now all this is a solved, right? So long time it's taken. Okay, now here it's going to take very short time because everything is being added into the network and you can track them. And nobody accepts some mistake, but here you can track down the issue. Okay, where the actual issue is. Tampering a data, you cannot tamper the data because it is a blockchain based application. Okay, so immutability, so it solves this problem. Centralized database, no, it's not centralized now, it is decentralized, kind of decentralized but private. Okay, payment issue can still be resolved by using a crypto. Okay, so this is how your solution will be, right? So that means when you use Hyperledger Fabric and it solves your problem. Okay, cool. So now what we've understood is if we redesign this entire application in the Hyperledger Fabric, yes, we solve all these problems. Now let's talk about the technology aspect of it. Okay, now we are the company who are the, what do you say, that the developers who are going to develop this kind of an application. Now let's talk about how we're going to develop this. Now, if you talk about any application development, the architecture is still going to be same. Okay, the application architecture. I'll talk from bottom up. Okay, so basically you need your database, which is your backend, and then what do you need? You need your APIs, and obviously your front-end application. It's very simple, but you can make it more complex as well by using microservices or distributed architecture and things like that. So we'll talk from right to left. So now we are redesigning this application in Hyperledger Fabric. So the first thing what you need is the database. So for that database, what we are going to design here is we're going to build the Hyperledger Fabric network. Okay, so this network will consist of all the organizations. So that means whatever organizations we have, all the organizations will be hosting their own ledgers. Now, these are our organizations. Okay. Now, what happens here is, first thing is we need to build the Hyperledger Fabric network. That will be your first step. So you design your Hyperledger Fabric network. While you're designing your Hyperledger Fabric network, you will be mentioning in my application or in this entire network, how many organizations are there. We have one pharmacy, one hospital, that's a organization 2, wholesaler org 3, shipment org 4, org 5, org 6, like that. You'll be creating this many organizations. And inside every organization, there are a lot of components which you will be designing. Now, once you create your infrastructure, once you create your underlying the network, right? Next thing what you need to do here is the smart contract development. Okay, so let me just move this guy a little bit towards left. From a developer point of view, what we also need to do here is we need to write our smart contracts. So in Hyperledger Fabric world, we use this word called as a Chaincode. So Chaincode is nothing but a smart contract. So now here, this is where I'm going to write all this smart contracts. Okay, now here you can write this smart contract is nothing but actually your business logic. Now what happens here is when this producer is trying to insert some data to the database, what is that logic we're going to follow? How this data will be, what kind of data will be inserted, and are there any calculations? Are there any business logics? Are there, right? So we will be writing that as a chain code. That's a smart contract. And these chain codes, you can write it in multiple languages. You can write it in Java, you can write it in Node.js, Go language, right? These are the 3 languages what it supports. And once you write this chain code as smart contracts, the next step what we do here is we need to deploy this chain code onto the every organization. Okay, so I'll just put it here. Deploy chain code onto this organization. Now to develop this chain code, we'll be using this Fabric APIs. Hyperledger Fabric APIs are available. Using that API, you'll be developing this chain code, and then you'll be deploying onto the particular organ. There are a lot of details. We'll go a little later. Now, what do you have here? You have your backend database network is ready, and then you have your chain code which you have developed, and then you have deployed the chain code onto the organization. So now once your backend is ready, then your middle layer, this can be your APIs, means application programming interface, nothing but your HTTPS endpoint. These APIs, what it will do, you can use something called as a Fabric SDK. So Fabric SDK comes with Java, Node.js, and then the Go language. So using this Fabric SDK, what you will do, this Hyperledger Fabric SDK, you will be able to talk to your network, Hyperledger Fabric network. And inside your chain code, this is where you written your smart contract, right? It's basically is nothing but what you have written is you have written some functions, right? Basically, for example, insert data, get data, or calculate some numbers or whatever, right? You have written a lot of functions. So now from the Fabric SDK, you will be executing or you will be calling these functions by using Fabric SDK. What this Fabric SDK will do, it can be any language. You can write it in all the languages. By using this SDK, it will allow you to connect to your Hyperledger Fabric network and then connect to a particular smart contracts running here, because you will not be able to access every contract running on it. You can run multiple smart contracts here for multiple reasons, for multiple purposes. And then Fabric SDK, using Fabric SDK, you'll be able to execute them. And after that, it's a very simple one. So once you have your API, then you have your UI. From UI, you just call this particular API. So your UI can be anything. UI can be your web applications or mobile applications or whatever kind of applications. And here you can use any front-end technologies like Angular or React or Vue or something like that.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
So this is how, on a very high level architecture, your application is going to look like. Okay. Now here, the organizations, when we say organizations, you're setting up your Hyperledger Fabric network, right? So when we say network is nothing but there are a lot of peers we're running, okay? Your anchor peer or endorsing peer and a lot of components which will be running. All these are Docker containers here. So everything, whatever you see here, these are Docker containers. When we go to our network setup, I'll talk about Docker as well so that you understand what you're doing. Okay, so we understood why we need Hyperledger Fabric and then and how this can be solved. Okay, and then we've also learned about, if we were to build this application, what we can actually do this or how we can use Fabric API, Fabric SDK, and then your network. All right, okay. Now let's talk about this Hyperledger Fabric. Yeah, some things will be whatever we have discussed, but I'm just going to cover it a little bit faster. Okay, so business network, traditional versus blockchain, which we have seen here. Centralized in nature, centralized ledger, like where all the entities are entering it here. But whereas in the distributed ledger, each organization will have their own database. See, now one thing what you need to keep in mind here is when this guy, factory guy, is inserting a data into this ledger, that data is not gets copied only with this guy. Okay, so this data will be copied onto the shipment organization as well, wholesaler organization as well, right? That's why we call it as a distributed ledger. Obviously, one challenge what you can immediately think of is if there are too many data getting inserted, and then obviously my database size will become bigger and bigger, and then I'll have to pay a lot of money to maintain my infrastructure. Yes, there is. So that's why what we always say here is in Hyperledger Fabric, you don't need to save all the information by all the organization. Whichever you are interested in, you will be saving that. Otherwise, you don't need to. Okay, that's another thing here. So everything is of distributed ledger, and when we talk about Hyperledger Fabric. So blockchain for business. Another thing to differentiate your Ethereum and Hyperledger Fabric is Ethereum is more like, let's say I want to build a YouTube on a blockchain, or I want to build Facebook, I want to build a messenger app, I want to build some games, I want to build some Ola application, Uber application, I want to build a rental as application, and we'll go with the blockchain based, or any games or NFTs, a metaverse and crypto world exchanges and things like that, right? But whereas Hyperledger Fabric is majorly designed for the enterprises, so where only the known entities can join. For example, in this network, I cannot just join this network. If I can just get in and see, oh, I want to see what's happening inside, who are you, right? You're not authorized to join the network. One- Once you have permission, once if any of these organizations have given you permissions, or most of the organization given you the permission, only then you can join this network and see what's happening inside. Unlike your Hyperledger Fabric, sorry, unlike your Ethereum. So that means Hyperledger Fabric is used to solve a lot of enterprise issues. Okay, a particular enterprise you take, and then you can develop an application to solve that particular business problem. Can be anything. One is the supply chain I mentioned, supply chain in retail, supply chain in the healthcare industry, supply chain in the government, and wherever you see, right? Wherever you see, you're looking for a traceability, and then you're looking for a immutability, and you're looking for a smart contract, and then you're looking for a decentralization. And very important thing, not everyone can join the network. It's more of a permissioned based network. Whoever has a permission, only they can view. Then you will go with Hyperledger Fabric. So it's basically we use it for the enterprise businesses. Okay. Blockchain for business. It's a mix of common, unaltered record that streamline business procedures and open new doors for the advancement. Consensus in blockchain is organized between individuals, which wipes out expensive dangers and wasteful aspects as a resource and change hands altogether business. See, one thing what we understand here is, if you know more about Ethereum, the consensus is very strong. You can really trust that. Right? We all know that in the Bitcoin network there are billions of money involved in the Bitcoin network. Now the price have come down, but otherwise it's a billion dollars is present in that Bitcoin network. The reason why people buy Bitcoin or Ethereum is because the network security is very high. Is no one in the world can hack Bitcoin or Ethereum network. Immediately something comes in your mind. Oh, no. I've heard a lot of stories where people are hacked Bitcoin or any other. No, nobody was able to hack Bitcoin or Ethereum network, but people were hacked the exchanges. Now, what happens in this Bitcoin network is, the network is so big. That means there are thousands of nodes in the world, and whenever any transaction goes inside that, and this gets mined by using the proof of work algorithm. So what this proof of work algorithm does is, they need to identify a one particular number, nonce. Once they identify that number, they generate the hash code with the leading zeros. So the more the zero leading zeros, more difficulty. More difficulty, that means they need to invest a lot of money in their, basically their compute power should be really big. So they should have a very good powerful computer which can compute it. So that means just to compute that hash, they will be investing money, and then they calculate it. Because of that reason, hacker they just cannot just come in and then try to hack into that Bitcoin network. Even if we try to do that, in the network, it's not only one node. Okay, there are so many nodes in the network. He'll have to hack at least 51% of the network to hack it, which is impossible. And he's going to invest so much money to hack the network and get it. So instead of that, what he'll do, no, I will just participate as a miner. At least I'll make money there. So otherwise, I'll not be able to hack anything. So that's why we say the Bitcoin or Ethereum network is very secure, because that uses a proof of work algorithm. But whereas when you come to Hyperledger Fabric, and that is called as a consensus. Consensus means, it's a very simple English term, is how are we going to agree upon the data, right? Where we want to insert some data to our network. On what basis we are agreeing that yes, okay, this data is valid, right? That is called as a consensus. So in Ethereum, we have proof of work as a consensus algorithm, but in Hyperledger Fabric, so we also have a consensus. Okay, so but unlike your proof of work or a proof of stake, it doesn't involve too much electricity or too much of compute power. But whereas here, what we say is on a very simple term, let's say, right? Now the shipment organization and factory organization, they will discuss that, you know what, whatever data you as a factory is trying to insert, I want to validate the data. I approve it, only then the data will go inside. Because I cannot just agree upon what everything and anything and everything you insert it, right? That is called as a consensus. Now, the data what goes inside this ledger, the shared ledger from a factory, is that data is being accepted by the wholesaler, accepted by the hospital, accepted by the pharmacy. If all of them agree, yes, okay, this data looks good and I want to insert it, that is called as a consensus. And all this thing happens programmatically, okay, nothing manual here. So everything is a program. Or when we initiate a transaction, the agreeing to that particular data which is getting inserted, it's all automated, right? Everything is a program, and then which gets inserted. So that's your consensus mechanism in Hyperledger Fabric. So we'll go a little detail in how we do that. This enterprise-ready blockchain platform makes it easy to activate and manage a secured business network across multiple organizations. So you can build a secured blockchain network using Hyperledger Fabric as well. And more of a, what do you say? You need to have an additional security layer in your database, but otherwise people cannot simply join. Okay, so now what we are looking for here is we are looking for the shared ledger. We have discussed here in this diagram. We have a shared ledger. And we're looking for the smart contract. So the business terms embedded, all your business rules, business logic embedded in the transaction and database and executed with the transaction. And consensus, all parties come to an agreement on the network verified transaction anonymously. And there's also privacy in Hyperledger Fabric or the private blockchain. It's a very important concept. Ensuring appropriate visibility, and if the transaction is secured, authenticated, and verifiable. See, now one real use case I'll give you. This wholesaler is selling one asset, syringe, to hospital, and is also selling the same syringe to pharmacy. Now, what we want to have a privacy here is this wholesaler is giving, let's say, 1,000 product to hospital, the same product daily, but to pharmacy is giving only 100 because they require only 100, right? But they require 1,000. So because these hospitals are buying in a bulk, he will sell it for the cheaper price. He might sell it for, let's say, $1, but here he might sell it for $1.5. Okay, but this number, whether they're selling it for $1 or $1.5, we want to keep it as a private. Okay, so that is called as a channels in Hyperledger Fabric. So we'll go a little all the details there. So for example, now what do we do between this and this? Now we want to have some privacy. Okay, so for that reason, what we can actually do here is we can create one channel. We'll go a little detail there. Okay, so what I'm telling here is, so now we have this channel particular. So in this way, so there is a privacy within the network. And all of them are agreeing that yes, okay, you need a privacy. You can have a separate channels. Okay, that's here. Let's move on. Let's talk about Hyperledger Fabric. Sorry, as a Hyperledger as a whole. See, permission blockchain is also a private. Okay, the major difference would be, so there's basically two things. One is a public blockchain and the private blockchain. So what is private blockchain? I am building a blockchain network which is private. That means not anyone can join. If you have a permission to join my private network, then that becomes a permission network. Right? So another analogy I'll give you. I have my house. This is private for me. Okay. A random person cannot just walk into my house, right? Because this is not a public network. This is a private house, private network. But my friend can actually come to my house, right? Because he has a permission to come in. So like that. Yeah, got it. Okay. So who provides a permission? I provide him a permission. That in Hyperledger Fabric, you use like certificate authority or something like that to issue the certificate to these guys. We'll talk more on all this. Okay. So now, so far we've understood uh, when would you use Hyperledger Fabric, and if you were to design the Hyperledger Fabric application, what is the architecture of that? Yeah. Now let's go in little detail of this. See, when we talk about Hyperledger Fabric is one of the product in Hyperledger, but there are many products available in the Hyperledger. So Hyperledger is actually a open source project, and it's being contributed by many organizations in the world. Major, there's so many companies have contributed to this, and this Hyperledger project we call Hyperledger project is started by Linux Foundation, which is open source. Your Kubernetes and Node.js, all these things comes under Linux Foundation only, backed by technologies, financial, banking, and supply chain companies and worldwide. And it's an open standard. That means you can, when you look at Hyperledger project and you start to use Hyperledger Fabric, let's say, right? And you realize that, you know what, I'm looking for some functionalities and I don't see those functionalities here. You can do two things. One is you can contribute to the fabric itself. Because it's an open source, you can build a new features, new functionalities. You can have them available to the entire world. Or you can even fork that, and then you can customize and you can build your own Hyperledger Fabric. Like you can call it as like, Arjun Hyperledger Fabric, or Arjun Hyperledger also you can call it as. Okay, so now IBM has contributed a lot to this particular product. So let me just go to Hyperledger website. So Hyperledger Foundation hosts a number of enterprise-grade blockchain software projects. These projects are conceived and built by developer community for the vendors and the end user organization, service providers, startup, academies, and other users. So anyone can take this project and build your own thing. See, Hyperledger Foundation is a part of a larger Linux foundation that explains okay, whatever. And the reason why we go for Hyperledger project is it is modular. They kind of they built everything as a Docker container so that everything is isolated. And even the consensus algorithm as well, you can plug and play consensus. Highly secured because it is a permission blockchain network. And whoever needs to join the network, they need to have a certificate with them. Only then they can join this network. It is highly secured. Considering it is a private blockchain, so you can build additional security as well on top of your network. Interoperable, so you can run this on multiple environments. Like if you built it on Hyperledger Fabric, you can even try running on Hyperledger Sawtooth as well. Cryptocurrency, we don't use crypto in the Hyperledger Fabric, but you can still use it, right? In this example, I mentioned that the payment, we still go with the bank. We keep bank as an intermediary person and they will pay the payments, right? But whereas in here, you can still integrate with the Hyperledger Fabric with any other crypto as well. Famous is Stellar, but I think they have support now. They might have added support for other things as well. So completely with the API, so everything is built in API internally, and it makes it easier to work with or develop applications. Hyperledger Foundation goals: provide a neutral, open community around enterprise blockchain, supported by technicals and the business governance. Foster the development and adoption of cross-industry platform powered by distributed ledger. So what some people have done here is Hyperledger can solve problem in retail, in healthcare, or in mining industry, or in power and electricity, and a lot of things, right? So you can even build a specific Hyperledger project to solve a particular business as well. Educate the public. Okay, why enterprise blockchain? Why Hyperledger? Blockchain solves a core problem. Many organizations want to share data, the distributed. Whatever we discuss, kind of going to be the same repeated. But no single owner will be trusted by every user. Blockchain technology enables direct transactions in a secure, and transparent way, backing trust into the system to operate at the efficiency of a peer-to-peer network, right? See, one of the big thing about blockchain is the only technology which will bring a trust in the trustless system, right? Where I'm doing a business with someone who's in Africa, let's say, right? And obviously, without a blockchain, I'll have to involve bank or any third party to enable the trust. But whereas when I go with the blockchain application, the technology itself provides a trust. For enterprises, adopting this technology is making foundational changes on how they conduct a business. When used on the enterprise software solutions, it enables trust where it didn't exist before. It removes the layers and layers of inefficiency, right? And you remove all the intermediaries here. The technologies of building block for core cross-industry systems that will only scale in the size and complexity as well as effectively in the value. Because Hyperledger technology open source code base built with a collaborative design and governance, enterprises have embraced them, a trusted infrastructure building a solution. Because open source, you will see that there's a lot of new features and new development takes place in the Hyperledger world. Now, there are so many. I mentioned that Hyperledger Foundation is the base project. Based on that, there are people have modified versions of this Hyperledger Fabric. So if I go back to our diagram here, we kind of know this problem with the existing blockchains, characteristics, description of the platform. Ethereum is a generic blockchain, but whereas a Hyperledger is a modular blockchain framework. And there's one more we have called as a R3 Coda. R3 Coda is it's a private blockchain. It is developed by a company called R3, and this again it's a permissioned and the private blockchain. And one thing here is this is controlled by a company R3, but whereas here this is a open source. Hyperledger is a open source. Ethereum, it's a Ethereum community. Mode of operation, Ethereum is a permissionless, that's public. You can also have a private, but not many uses it. But the Hyperledger Fabric, it is designed for the permissioned, or you can build a private network as well. Private network is only for yourself. So I'll give one use case here. I have an organization. In my organization, I give salary and I give bonuses and I give some incentives to my employees. Now, considering this is a financial thing I'm doing, there can be any fraud in between, like whoever is doing that. So what I could do here is I can build a Hyperledger Fabric solution and then only for my company, okay? And whatever the salary or bonuses and I pay to my employees, I will record them in this particular ledger. So that I have this immutability, I have traceability, and I have smart contracts, I can do something like that, right? That's why you go with the private blockchain. And similarly, R3 Coda is same. Consensus, it's a proof of work here. And here it's more of a broad understanding of consensus allowed multiple approaches. All the organizations within Hyperledger Fabric, on what basis they're going to agree, right? It is an endorsement, we call it as. And here, specified under a consensus, we don't want to go here. Smart contracts, you can write a smart contracts in the Go language and Java, and then your Node.js as well. But even here, it supports Kotlin and Java. And currency doesn't use a currency here, but you can still integrate with that. So this we have seen goals of Hyperledger Fabric. So we have open source team builds diverse approaches for business blockchain technology system, creating enterprise grade open source ledger frameworks and the code to support the business transaction, providing neutral and open community driven infrastructure because it is not defined by any organization. It is from the global community. Building a technical communities, educating the public and promoting the communities. Okay. Now let's understand how this Hyperledger works. I'm not going to the Hyperledger Fabric yet. We're still talking about Hyperledger Foundation. But kind of this is similar, how Hyperledger Fabric works. I'll just quickly take a look at this 1 second. Okay, before I go to that, there's already a slide which talks about there are other frameworks here, but quickly I'll talk about them 1 second. Give me a second. Okay, now in the Hyperledger Foundation, there are so many projects, as I mentioned. You can see that here, graduate Hyperledger project, Hyperledger Ares, Hyperledger Besu, Hyperledger Fabric, Hyperledger Indy, Hyperledger Iroha, Hyperledger Sawtooth. If you see in all these projects, you can see there are stars here, you see, right? 20,779 stars with 1,000 stars and 670, 1,700, 910, and 1,400. There are so many projects people have developed under Hyperledger. Hyperledger Fabric is something which is famous when many people uses it. Okay, so there's all the links have been given here. Hyperledger Fabric, GitHub link, and Hyperledger Fabric Twitter link, and everything is here. And there are some tools also people have developed. These are basically your frameworks, and some other projects like Hyperledger, Bevel, Kaku, so a lot of things are available here. All right, okay, so now let's move on to this. Okay, now let's understand how this Hyperledger actually works, Hyperledger Fabric works. We're going to talk about more on the Hyperledger Fabric from now on. Now here, when we talk about any transactions in the Hyperledger Fabric, take a use case where factory is trying to insert some data into the ledger, Hyperledger Fabric ledger. Let's understand how this insertion happens. There's a lot happens, when they execute a particular smart contract. They execute a smart contract that will insert a data, right? But you cannot blindly insert some data into your ledger. The first thing, what this factory or anyone who are trying to insert some data, what they will do here is they will create one proposal. They will send one proposal telling that, I want to execute this particular smart contract where it is inserting some data or it is modifying some data into the ledger. Once the proposal has been submitted to this network, in the network, we would have programmed something called as a endorsement policy. So now what we are telling here is, now I'll just put this two things here. Now I'm going to call this as a Okay, so we'll call this as an endorsement policy or endorser, I'll call it as. So what we are telling here is, whenever I'm trying to insert some data here to this ledger, these two endorser should accept my request. They will validate the request and they will say that, yes, okay, whatever data you're trying to insert, we are having a consensus. We are agreeing that the data what you're getting inserted is all looking good. Yes, you will be able to insert it. That is called as an endorser. This is very important because this is how your consensus happens here. So now, whenever this proposal is being submitted, in every network or every peer or every organization, you will have an endorsing peer. But you would have programmed that who needs to approve. Even here, you have an endorser, but does this endorser need to approve this? Maybe yes, maybe not, right? Based on your use case. So now what happens here is you have an endorsing peer. What this endorsing peer will do here is they will first validate your incoming request. First thing is, are you the authenticated person? Do you have the proper certificate with you? Are you allowed to execute any transaction? And is that signature is your private key? And do you have a certificate? Everything. Once they execute that, and then they will, next thing what they'll see is, when I say they is, all your Docker containers, okay? So your endorser. So your endorser will check what is that smart contract or chain code function which you are trying to execute. And what is it trying to do? Okay, so it looks like this is trying to edit some information. Now, when it is trying to edit some information, now I want to simulate that this endorser will not insert the data yet. Okay, it will just simulate the incoming request. So what this endorsing peer will do, execute the chain code to simulate proposal in a peer. Query state database for a reads and build a read-write set. Now, what this endorsing peer will do, it will create something called as a read-write set. Read-write set in the sense, so there is an asset here. In our case, it's a syringe, and factory is trying to enter some detail about the syringe. But in our ledger, we already have a detail about a syringe because the raw material guy was given some given some material, and there is an entry has been made, or even if it is a new entry, it is going to make. Now, what we do here is we create something called as read write set. The read set will have a version. So telling that asset 1, version 1, asset 1, version 2. So what are the other past information we have? It creates a read set. What it also creates is another one is called as a write set. Write set will be once I execute this function, the proposal, whatever is given, how would my database looks like? When I say database is nothing but your ledger here. Okay, how my database is going to look like? It creates these two, and once it's validate this and it checks everything, then it responds back to the incoming request. Right here, we give an application SDK. In our use case, the factory organization is sending a request. Right, it sends a proposal telling that you know what, I'm declining your request because it doesn't fall under the endorsement, because this endorser it did not agree your information what are you trying to insert, or we both are agreeing to your incoming request and we are approving your proposal. Okay, and we're going to send this back along with the read write set. So what version of data will be changed, and then what is the previous version, both the data will be given back to producer, sorry, whoever is sending the request. So once it receives the response from endorsing peer, then it will submit the request. Now, okay, now I got it approved. Now I want to insert this data onto the peers. Onto peers means it will get inserted in ledger here, or even other interested organizations as well. So then the transaction will go to something called as a ordering service. What this ordering service will do here is, we'll go into detail on all of this in the next slides. The responsibility of ordering service is it will make sure that every transaction is kept in the right order. Now,
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
factories created a transaction, shipment is created a transaction, wholesalers created a transaction. If many things come parallelly, the orderer needs to make sure all the transactions are kept in the right order. Before inserting factory information, I cannot insert shipment information on the same asset, right? We need to make sure that the concurrency is being maintained and that the integrity is also being maintained. So this ordering service, once it receives the request, it validates, okay, looks like you already have a proposal accepted from the endorsing peer. Okay, cool. Now I will pass this request to all the peers. Now what this ordering service will do, I'll just put one ordering service here. So this is our ordering service. What this ordering service will do, ordering service understands that, okay, so I got this response here. Okay, yes, okay, now I will tell both the peers to insert this data into their ledger. Okay, that's what ordering services will do here. Now, what the ordering service, when ordering service gives the information to all the peers in the organization, this is where your peer, like within your organization, you have a peers here. These peers is where the actual data gets stored, validates each transaction and commits the block. And this is where it actually executes the Chaincode function and it inserts the data into the ledger. What it does, it validates the endorsement policy, whether we got the validation, validate the read set version in the state database. So we'll go a little detail. We have like something called a state database that's called a world state. Also, we have a log and commit block to the blockchain. That means your world state ledger. So when we talk about database in Hyperledger Fabric, we use two terms. One is the world state, that is having a current information. We also have another database called as a log information that will maintain the history. So that will validate the read set, whatever we have received here, read set, the versions of state database, and commit the block to the blockchain and commit the valid transactions to the state database. So what happens here is, now this particular asset one, I will take it as, you have a first syringe, we're calling it as asset one. Now this asset 1 will move from factory to shipment to wholesaler to hospital, right? There are on a very simple terms, 4 transaction happens, let's say, right? Now in our database, we will not insert 4 rows in the database, right? What we do here is, this is unlike Ethereum. We will insert a row telling asset 1, the owner is factory. The moment it gone to shipment, we go to the same row, update the value. Asset 1, now the owner is shipment. Now when it comes here, asset 1, the owner is wholesaler. That means you can delete a content in the ledger, you can update the content in the ledger. You must be wondering where is blockchain here, right? And how are we able to delete it, right? That's the thing here. Now, what it does here is when it inserts a data, it inserts into 2 different databases. One will have only the current state. On this particular asset 1, syringe 1, you have made 30 changes, but there'll be only one row always exist, which will have a latest information. But whereas you have another database called as a transaction log, that will have all the changes made to that particular asset. So whenever you're looking to grab the history, whenever you want to trace it, you'll go back to that log and then get that particular information. Okay, that's a major difference between Ethereum and then the Fabric. And then once this happens, yes, your block is validated and the new block gets created in this particular ledger within the channel. All right, so let's continue. Now let's understand the same thing, a little detail here, how it works. So now what we have here is, we have the complete network here. Within this network, what we have here, we have the network node, that's your organization A, organization B, C, D, like that. We have many organizations. A blockchain network, a chain network that services solutions built for a particular industry. A shared ledger records all the transactions across the business networks, and consensus, the transaction validation and the commitment. Proprietaries set up and they define a purpose of the chain network. They are shareholders of the network. In our case, the hospital, pharmacy, wholesaler are the proprietaries here, or organizations, what we call it as. So now what happens here is, end user typically initiates transaction on the chain network through the application made available from the solution provider. Now, one thing what we see here is, if you look at this diagram here, you have written the chain code and you have written the API and then you have written the front end. This front end is not one front end for entire network. Keep that in mind. It's completely different. Whatever factory inserts a data versus what hospital inserts a data, it'll be 2 different information, right? So that means this designing this front end and then the Fabric APIs and even the smart contracts will be differs from this guy to this guy. So, but if anyone inserting from factory, they will use the front end application, web application developed by factory. Similarly, hospital, they have developed their own web application, but both will be inserting into the same ledger. Okay, so public transaction with its payload and in the clear format, and non-validating node constructs transactions and forwards them to validating nodes, peer nodes. Keep the copy of all the transaction to the solution provider can query, right? Every node will have this transactions. And organizations that develop mobile and web applications for the solution users to access chain network, they own either the network or the validating node. And then now there can be 2 things. One is this hospital takes ownership to build this entire UI, or each organization takes ownership to build it. But if we were the developers, and we'll be developing everything. And we also have something very important called as a membership service providers. Okay, so this is where all the certificates is being issued to the participants. Whoever participates from this factory or any organization, they need to have a certificate. So what we do, we have a registration authority. assign registration username and password pair to the network participants. This username password will be used to enrollment of the certificates. Okay. So now any user who need to participate in the network, they will be given a private key and the public key, and that will be issued by the certificate authority. And they need to enroll first to our network. You will do all this when you do the hands-on. Enrollment CA issues enrollment certificates to the network participants that have already registered with the membership services. Now, what happens here is in all this network, you will have a certificate authority, root certificate authority. That root certificate authority will provide admin certificate to every organization, and that every organization will provide a certificate to their participants. So that you're distributing modular, you're making it. And transaction certificate, issue a transaction certificate to the e-certs owners. An infinite number of T-certificate can be divided into each certificate, and the T-certificate used to network to participants in transaction. To send a transaction, you must have a certificate. And we also have a TLS, that's your SSL kind of certificates to interact with the network. All right. Okay. So now what we have? So we have the network here, node A, B, C. So that will be given by the certificate authority of organization. Yes, each organization will have a certificate authority. And then in every network, in every nodes, whatever the chain code, the business logic we have written, we're going to deploy it on that. Okay. So you might have many chain codes here. It's not a one smart contract, one chain code you're writing. Now, whatever the data he's going to insert it, he would have written one chain code. Similarly, shipment would have written one chain code. Wholesaler would have written chain code. And another thing I explained here, right? These chain codes, we don't directly insert on the ledger. Instead, these chain codes will be running on the channel, because these channels are the one which puts a privacy. Now I'm running one chain code here. That chain code must be accessed only by wholesaler and a hospital. Okay, so that means that chain code will be running on this particular channel. So you will have many smart contract chain codes are running here. Chain code state, we know chain codes access internal state storage through the state API. States are created and updated by the transaction calling chain code functions within the state changing logic. Now your ledger gets updated when you execute a chain code. Chain code is the one which has a permission to modify your ledger data. Confidential chain codes that only predefined subset of validator can view and execute. Like I mentioned, within this network, we have two organizations. Only they want to see your chain code will be running on that. Only they will be able to see those chain code and then execute the data as well. All right. Okay. Now, when you were to build this applications, right? As I mentioned, if I come from the between here, you can choose Hyperledger Indy, Hyperledger Iroha, Hyperledger Sawtooth, or Hyperledger Brook. There are differences between each one of this. I encourage you guys to go through and read. What is the difference between each of them. But what people majorly use is Hyperledger Fabric. Differentiated approach to the business blockchain framework, developed growing community, whatever, right? And with respect to infrastructure, so CloudFront is a third party, and Node.js and Hyperledger, and these are the other things which is being maintained by the Linux foundations. And they also created some products I've showed you, right? And these are some tools, okay, which you can use it on this. These are not frameworks, but more of a tools. Okay, so then next, the Hyperledger architecture kind of looks similar what we have seen there. Hyperledger reference architecture is aligned with 3 categories: membership, blockchain, and a chain code. These categories are logical structure, not a physical depiction. A partition components is separate process, address space, and the virtual machine. So when you're running this, you'll be running many components. End of the day, it's just a one virtual machine, one VM, one computer, and inside that you'll be running all the components, small components as a Docker container. Same thing here. So you have an application that sends a request. You send the proposal to the peer. Now you see this in a peer, in the organization within the peer. So peer inside the organization, you will have these many guys. You will have endorser, you will have committer, you have ledger, you have chain codes, you have events running here. Okay. Now endorser we discussed. Endorser is the one request the receive process and then responses. Okay. Before even you send a proposal, you must have an identity, right? That will be provided by the membership service provider. So the membership service provider, they need to enroll with the membership service provider. The membership service provider will issue them the certificates. With that certificate only, the request will be given to the endorser peer. And after that, we know that, and then it receives a request, it sends, submits a transaction to the ordering node, and ordering node will talk to, see here, say order here. Ordering node will talk to the all the peers to update the ledger. All right. Now let's talk more on the membership service provider. So now what we see here, you have membership service provider, and inside this we have Fabric certificate authority and external certificate authority. We have two certificate authorities here. Now here, this is our network. Now an abstraction of identity provider. So we use something like a MSP, membership service provider. We use this ID and we create a signature and we create a verification, then we create an admin. We create an admin for every organization and governs the application, endorser and order and identity, and uses as a building block for access control framework. Without certificates, you cannot do anything in the Hyperledger Fabric. So what it does at the system level, what read write you can actually do that can be controlled. At the channel level, what are the channels you have access to, what are the channels you can read, what are the channels you can write into, that also can be controlled here. On the chain code level as well, which smart contract invocation you can do, which smart contract invocation you cannot do. Everything is being controlled here with the MSP. Okay, so now here we're using something called as a composer here, but we don't use that composer anymore. Composer is a, I don't know, is it still working now? Composer, yeah, they removed that. The composer was one tool, open source community developed it, that using that UI application itself, you'll be able to work with Hyperledger Fabric, so that we don't have that anymore. They've stopped developing on that. Okay, let's talk about Chaincode now. So now let's recall. So things what we know for now is in the Hyperledger Fabric network, when we talk about, we have a lot of components here, and these are like your endorsing peer, committing peer, and you have your ledger, and you have your ordering service, and you also have your certificate authority. And we also create a channel between the organizations, and you will deploy your chain code on the channel, right? Chain code is your smart contract. A chain code is a piece of a code that lets you interact with the network's shared ledger, right? And on how are you going to insert any data to your ledger, or how are you going to read data from your ledger? You will be writing a program in this chain code. That's your program. Whether you invoke a transaction on the network, you're effectively calling a function in a piece of a chain code, right? It's end of the day, it's like any other code. If you're writing a C#, Java, or any other program, in your chain code, you will have functions and you will have variables. So you're just executing one function like insert data, read data, calculate data, right? Whatever, right? Something like that. Chain code services uses Docker to host a chain code. Okay, I've been talking about Docker, right? I'll give some background on what is Docker, so it helps us to understand better. Okay, take a look at this diagram. Now we all are part of a team. In our team, I am one of the developer, and the project what we are using is something like this. It has 4 layers in this project, and the project one is written on Node.js, and database is MongoDB, and I'm using some messaging system here, I'm also using Ansible to provision infrastructure. Now, in my local system, I have set this project. Very complicated setup I've done in my local laptop. What I have done here is to run my Node.js project, I need Node.js 8 version. Okay. And I need CentOS operating system. I've created one virtual machine and I've created a CentOS operating system. Inside that, I've installed Node.js 8 version. I'm running this project. To run my database, I'm running it on Ubuntu operating system, and this is running on, let's say, Node.js 12 version. Okay, then I've created another virtual machine to do this. And for the similarly messaging, I'm using a RHEL system. This is running on Python 2.7. Similarly, Ansible is running on the Python 3.5, let's say, right? Now, what you see here, this is called as a matrix from hell. That means my project setup just for the 4 projects, right? I mean, this is for a one application. Take an example of Flipkart.com. For the Flipkart.com, I'm written 4 projects. Now, just to set this up in my local laptop, I'm going to spend so much time and effort because there's a lot of dependencies. I cannot just run everything in the one machine because this requires node 12, this requires node 8. There's a mismatch, right? This requires Python 2.5 and Python 2.7. This requires Ubuntu, this requires CentOS. So when you have this kind of a setup, somehow it's working in my system. But when my developer, any other developer, if they need to have the similar setup, they will have to work with me and then set up a similar infrastructure in their computer. Okay, that means they're going to put so much effort to set this up. Obviously, that means what? They're going to take a lot of time to configure this. Not only this, when you want to deploy this onto testing environment, when you want to deploy it into staging environment, when you want to deploy it into production environment, you're going to take a lot of time to configure this. So to solve this problem, what I can do, I can use a Docker. So what Docker will do here is, in my laptop, let's say in my laptop, I'm running on Ubuntu. I'm running on Ubuntu. In my laptop, I will install this Docker tool. Okay, Docker, you can install it. It's a plug software. So I need to install this Docker. Once I install a Docker, unlike before where I was creating 4 different virtual machines. Virtual machine means it's nothing but creating a 4 computers, right? So I don't want to create a 4 different virtual machine. What I will do in my laptop itself, I kind of isolate all of this. Isolate means it's like I have a house. In my house, instead of just having a one big hall and then I'm doing everything in some random places, what I do, I've created a 4 bedroom here. Okay, so bedroom 1, bedroom 2, maybe another, let's say kitchen here or something like that. So I kind of create a isolation for all of this. Now for my first project, since it's running on a Linux Ubuntu machine, on top of this, I mentioned that I want a CentOS and I'm going to run on the Node.js 8 version. Similarly here, I'll mention I'm running on Ubuntu operating system, then I'm running on Node.js 12 version. Similarly, Python 2.5 and then whatever operating system, and similarly, I mentioned it here. And all these 4 are running on my laptop only. And I've created a complete isolation here. This is called as a Docker container. We're creating an isolation. Now, I'll give a good analogy here. I have an apple, and I want to send this apple to France, Paris. What I'll do, I'll go to this courier guys, and I'll give them this apple. They will package this apple, and they will give it to the shipment company, right? Huge ships. So what the ships they will do? They have a physical container. If you're seeing the metal container, big box, they will have a many containers, many physical containers. What they will do, they'll take my apple, it's a perishable item, they will place it in one of the container. Similarly, one of you, let's say you have sent let's say an electronic device, so they will not keep that electronic device in this container. Instead they will keep it in the other container. So The container where they have placed the apple, they will make sure there is a refrigerator in that container and it maintains a cool temperature. But whereas here, it maintains a required temperature for this. In that way, my apple will be still fresh even after 5 days when it reaches Paris. And in between, when it's moving from here to there, when it is moving from code, moving from my development to staging to production, no issues at all. It will work in everywhere because I have created an isolation and I have mentioned all the dependencies within the container. Okay, so now that's the same analogy. Now, when I create a containers, I create something called as a Docker images. Now that means for my 4 projects, I create 4 Docker container. I will call it as a image 1, image 2, image 3, image 4. And whatever the image I have created, I will upload it in the shared location. We call it as a image repository. Now, in the previous example, I mentioned that tester who wants to test into the testing environment and the operation engineer want to deploy to production environment, right? Earlier, they were taking 2 to 3 days of a time to set this project. Now you will not believe they will just take 1 or 2 minutes. All they do is they just execute a one command. They'll say Docker container run image 1, Docker container run image 2, Docker container run image 3, Docker container image 4. That's all the command they execute. Once I execute that command, my Docker will helps to create this kind of isolated environment in every place. Test, staging, development, and production everywhere. So that is the power of Docker. Now you can imagine Docker is like an isolation. Let me just put here. I don't want to go in little detail and all those things. But you can imagine Docker is like it packages all the required softwares and everything so that your project will run in any applications and people need not to install or anything. See another example. Now, if I want to run a project of Python, I need to come to this laptop. I need to first install Python 2.7. I need to make sure all the required software is there. Then I'll be able to run the project. But whereas in the Docker, nothing like that. Docker container run, boom, everything is running. It will automatically install everything. Similar thing, what we are going to do here is in our Hyperledger Fabric network, orderer, committer, and endorsing peer and everything requires a specific configuration, right? For all of this, we're going to use this Docker technology. Is any of you already working on Docker here? So if you know Docker, very good. Okay, so everything is a Docker container in Hyperledger Fabric. Okay, now you understand what is Docker containers. I'll continue here. Okay, so we're talking about Chaincode here. So Chaincode services use a Docker to host the Chaincode, as I explained. Docker provides a secure, lightweight method to sandbox Chaincode execution. Docker is also secured, yeah. Environment is a secured container along with a set of signed base images containing secure OS, Chaincode languages, runtime SDK images, and Golang. Now, even this entire network is actually Docker images. What Hyperledger has done here is all the major components like orderer, peer, endorser, and anchor peer, whatever you run, they have created standard Docker images and they have uploaded in the shared location called as a Docker hub. So whenever you are running your Docker containers, you will be pulling all these Docker images from their official Docker hub registry. So that means it is secured. Additional programming can be enabled. You can write anything here. Secure registry services, enable Docker registry for the Hyperledger Fabric, image custom, whatever, right? So all the container images which you pull from the Docker are secured from the Docker hub itself. All right, okay, cool. All right, okay, so let's learn about the consensus algorithm here. Okay. We kind of touched upon all this, but I'm going to read through this documentation and then if anything missed, I'll explain you. Because different industries, regions may run their own network, different networks might need to deploy different consensus algorithm to fit their usage scenarios. Now here, when I say consensus on a simple English term is agreement. How are we going to, based on what We are agreeing any changes to the blockchain network. That's it in very simple term. So it can be different agreement, right? The agreement between factory and the shipment is different from wholesaler and the hospital. Consensus algorithm under the Hyperledger protocol must be pluggable, allowing users to select the consensus algorithm on their choice of the deployment. Here it gives a complete freedom. We can write our endorsement policy telling that who will be approving this. This is called endorsement policy in Hyperledger Fabric. The Hyperledger protocol will provide an implementation of Byzantine fault tolerance. It's in the initial release using a PBFT. Okay. Byzantine fault tolerance means it is either all of us agree, either all of us are rejected. Okay. Only two scenarios here. It will not be like, I agree whatever he says, but I don't, this guy doesn't agree. It won't be like that. All of us, whoever we mentions the endorsement policy. Okay, to give an example, if factory need to insert any data, factory, shipment, wholesaler, if three needs to agree, yes, all the three must agree to that. So that's called Byzantine fault tolerance. So here, so what we do here is we kind of separate the endorsement from the consensus here. So what we have here in this diagram, so we have the client, and then we have the consensus services here, and in everywhere we have a ledgers running, and then we have another user here, like Alice and a Bob. Okay, now we want to do some transactions here. So dedicated endorser per chain code. Okay, we're going to create a big, because what we are doing here is each chain code is doing some changes to the ledger. So that means for that particular chain code, you need to have an endorser. And consensus service ordering for the endorser transaction. So whatever the endorsed transaction needs to be ordered. Yeah.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
So here what we do, Alice is here initiating a transaction, and then we have end user Charles, and who also initiating a transaction here. Okay, and all of them, they will be passing with the certificate authorities here. Okay, and then whatever transaction comes in here, we make sure that we endorse it, we validate it. Once everyone validates it, only then it will go and sit in the transaction. Let's talk about this API here. So we're going to use the API to create this transactions here. So whatever we mentioned here, so you have your Hyperledger Fabric network. Now, user A want to initiate a transaction, or a user B want to initiate a transaction. They will be using this SDK. If you compare this, they're using this Fabric SDK. They will send the request to the Fabric SDK. Your front-end application will talk to your network through Fabric SDK only. So in the Fabric SDK, using the Fabric SDK only, we'll be enrolling that particular user. We enroll that user and we provide the certificates and all the private key and the PEM key by using the certificate authorities. Okay, that's what happens here. So let's talk about more on this API. So in the API, this I'm talking about this Fabric API here. In the Fabric API, there are all these are programming. And wanted to ask you guys this one. On what language will you be writing these programs? Are you comfortable with Java? Java, huh? Okay, cool. Yeah. So we'll do everything in Java then. Yeah. So all these things, they provide an API in the Java. You'll be writing a lot of programs. So you need to have a prerequisite will be you need to have a programming background of Java, and you need to know the Ubuntu operating system and the Linux, obviously. And then what did I say? Docker containers. Okay. These are the 4 things you'll have to refresh. If you don't have an idea, please go back and study and so this API provides one as an identity. Using this identity class, we will enroll any users, okay, to get the certificates, also to revoke, like to remove that. So and it also has an address for the transactions. and API provides you storage. This is where your document gets stored. It can be a ledger or even external storage as well. And this provides you event, and more like publisher and a subscriber event. When he initiates a transaction, he publishes a transaction, and whoever is a subscribed to the transaction, they will receive it. Okay, that's an event. And transaction is nothing but any insertion happens to the ledger is called as a transaction. And we have a chain code API. Using this API, you will be able to write your chain code functionalities. And using this blockchain class, you'll be able to connect to your blockchain ledger. And the network will have a detail about your network. What is your Hyperledger Fabric network is, and on which port it is running, every other detail here. All right, okay. Now let's talk about the application model here. So what we have here, you have this underlying blockchain network here. An Hyperledger application follows the model view controller approach. The view logic is your front end, and the control logic coordinates among UI, data model, and the Hyperledger Fabric applications. And the data model is your manages off-chain, including documents, large file systems. So there's something called as a off-chain keyword what we use. Off-chain means if we store all the information in our Hyperledger Fabric ledger, it's going to be expensive because we are storing huge amount of data in the ledger. So, and that will become expensive, right? So in order to save, avoid that, what we can actually do, we can use some off-chain databases. Off-chain databases can be, it is not a Hyperledger, but it is anything else, any other database. So let me put it like this. Off-chain DB. This can be your SQL Server or MySQL or anything like that. Or even let's say AWS S3 bucket also, if you want to store any files, which is outside of your Hyperledger Fabric. What do we do in that case? You store some information here. You create a unique SHA-256 hash, and then you store this hash in your ledger. Okay, I'll just put a text here so that we know what we are doing here. Create unique hash and store hash in ledger. Okay, that's why we use our off-chain databases. Blockchain logic, extensions of the controller logic and data model into the blockchain realm, and control logic is enhanced the way how it interacts. Okay, for example, a platform as a service application, it's running on Node.js, might have a web front end user interface or a mobile application with a model provided with data management services. The controller logic may interact with one or more Chaincode processes. Right? This is same like whatever I explained here. So you can write your front end application in Node.js or it's .NET, C#, Java, whatever it is, right? But internally, you can. This is how things will be running. Moving on. This we have seen. There are different frameworks are available. You feel free to choose Hyperledger Fabric, Iroha, Sawtooth, and the front end as well. Okay, Hyperledger Iroha. I'm not going to talk about Iroha. We're going to focus more on the Hyperledger Fabric. Okay. I believe you guys have chosen Hyperledger Fabric, yes? Okay. Let's talk about Hyperledger Fabric mainly. We've kind of talked a lot on this. Hyperledger's first incubation project is a Fabric. This is the first project. Hyperledger Fabric was implemented in the Go language. The underlying initial support or a more support was given to Go programming language. Later, they added support to Java and Node.js as well. It's made for enabling consortium blockchain with a different degree of permissions. You can have different permissions here. It is a platform for distributed ledger solutions underpinned by modular architecture, delivers a high degree of confidentiality, resiliency, flexibility, and scalability. Right? We know that it is a confidentiality because you can create a channels that gives privacy. It is resilient because your ledger, you can create a multiple copies of a ledger so that it will never go down. It is flexibility. You have option to choose level DB as your ledger or a couch DB as a ledger as well. It is scalable. You can have a high availability system by, let's say, I have one ledger here. what if my ledger is down, the Docker container is down? Yeah. So in that case, you can create a one more copy of the ledger as well. So it provides you scalability. Key features: channels for sharing confidential information. We know this very well. Ordering service delivers transaction consistently to peers in the network. Ordering service makes sure all the transactions have been kept in the right order. Endorsement policy for the consensus mechanism, and a couch database for the world state. So as I mentioned, when we store any information in Hyperledger, you use two databases. One is a world state that contains the current state of the asset, only one row per asset. So where we use a couch database because we want a fast retrieval. Unlike Ethereum, it takes a lot of time, nearly 10 minutes for a transaction, right? Here we are expecting in a few seconds can be done because of we use CouchDB. Okay, we're using Hyperledger Fabric. It helps you to the identity management. It uses certificates, privacy and confidentiality because of the channels, efficient processing. That is because it's not a one component does everything in Hyperledger Fabric. If you have noticed properly, endorsement peer does the endorsing. Orderer container will be ordering it. You have your anchor peer that will receive the request. You have your committer peer, it will commit the request. So like this, different components have created for to do a different thing. Certificate authority to issue certificate. So in that will be it's very efficient system. Chaincode functionality, you can write smart contracts. Modular design, you can plug and play, right, like a microservices. Issues transaction with a derived certificate that are unlinkable to the owning participant, thereby offering anonymity on the network. Ensures that only the intended participant can see the content, right? This is on the privacy. And you can even encrypt the data as well with the Hyperledger Fabric. Okay, let's deep dive into this, some more aspects of the Hyperledger Fabric. See, I've been telling that there's something called as a peer-peer, right? So let's understand more on that. A peer is a node on the network, maintaining the state of a ledger and maintaining the managing chain code. Every organization, there will be a peer. Peer is nothing but your Docker container. So you see this in the peer, we have endorser, committer, submitter, ledger, chain code, and an event. Any number of peers may participate in the network. You can have any organization. Inside the organization, it can be any peer. A peer can be endorser, committer, submitter. An endorser is always a committer. Okay, endorser is the one who creates a read-write set. An endorser executes and endorses transactions. Okay, so it executes the smart contract and it creates a read-write set. A committer verifies the endorsement and validates the transaction result. Once the orderer sends the transaction, the committer is the one receives it and then he validates the transaction. Peer manages event hub and delivers event to the subscriber. If any changes happen to this ledger, it needs to tell other peers, then it uses events here. And peers form a peer-to-peer gossip network. Like the way the one peer, another peer, they interact using the gossip protocol. The way they exchange the information. Okay, let's talk about ledger now. So in the ledger, if you see here, so we have two things. One is the transaction log. Whenever you insert any data, right, you made 10 changes to one asset. What this transaction log will do, it'll create a one block for the transaction one. And then when you modify the data, it'll create a one more transaction. This transaction log is a read-only system. You cannot delete, update anything. You can only insert. And then the third transaction, fourth transaction, like this, for every transaction, every modifications you do, it makes an entry into this particular block. This is where it maintains a history of a changes. This is immutable. You cannot delete it. But whereas in the other one, we have the state database, it is a replaceable. So we use CouchDB here. This is a level DB here in this one, in this case. An external option supports a key query, composite key in key ranges. CouchDB is a very high performing database. This we call it as a state database. Latest written key value for the use transaction. The way we store information in this ledger is key and a value. Key and a value means age is equal to 30. Name is equal to this one. Details is equal to all the arrays of details, right? Everything is a key and a value pair in state database. You can imagine this is like an index. Okay, that means you have 10 changes you have made, but there'll be only one row available in your state database that has a latest information here. Whereas here it stores everything. By default, it's a level DB, but you have option to change it to which database. Okay, now let's talk about channel. Channel is a data partitioning mechanism to control transaction visibility to stakeholders only. So we have discussed this. To recall, it's just a communication channel between these two guys. Consensus takes place within a channel by the member of the channel. Okay, only by the member. Other members on the network are not allowed to access the channel when will not see the transaction on the channel. Okay, very clear. So unless until this guy is part of the channel, he will not be able to see the ledger, will not be able to see the chain code as well. That is how we agree upon. A chain code may be deployed on the multiple channels. Each instance is isolated within its channel. Whatever chain code you deploy, it is visible to only on that particular channel. And whoever is part of the channel, only they can see that particular chain code. A chain code may query another chain code in the other transaction by providing the access control. All right, so now that we understood about channel, we understood about the ledger, we understood about the peer, let's talk about the MSP. So you have membership provider, we have the Fabric certificate authority, and we have the external certificate authority. An abstraction of identity, so they need to provide this MSP credentials, governs the application, endorser and order identity, used as a building block for access control framework. At the system level, read-write access to the system controls and the channel creation, the channel level, at the chain code level, and everywhere. So you will be able to control on the different levels in your, basically you can imagine this as a authorization, both authentication and authorization. So they have a certificate, but what they can do on the channel, what they can do on the ledger level, what they can do on the chain code level. We'll be controlling all this with the MSP. And we have this crypto service provider. This is the one which issues all the PK private keys issuance. So CSP abstract the crypto standards, enables plugging in a different implementation. Alternative implementation crypto interface can be modify the code and supports. So the way it provides this, private keys. And you have a Fabric certificate authority. You'll be using this majorly. So what we have here, you have your Fabric certificate authority, which basically implements the member service providers. Okay, and it can be it can integrate with your LDAP as well. It can integrate with your HSM. That's another security mechanism. And they provide the certificates. Default implementation for MSP issues identity and a disposable certificate. Disposable certificate means only for the transaction, it issues a certificate and it revokes it. But this one will be long-term identity. Suppose clustering for a highly availability cluster, and you can connect with your Windows, LDAP or other systems as well. The integration, because if you already have an identity, and you can integrate with your existing identities. Okay, now let's go a little deeper onto this, the application flow. Now, I as a blockchain developer, now I have developed a smart contracts, right? Now I develop a smart contract, and then I trigger some event. In the smart contract, let's say I've written two functions, one function to write to the database, another function to read the database. Now, when I execute writing to the database, that can be a put or a delete, right? Put means, you're inserting or you're updating it. You're deleting a record. You can delete a record as well, okay, in Hyperledger Fabric. So in that case, what happens here is it makes a two entry as we discussed before. One is your transaction log that is called as a blockchain because it cannot delete it, and also it makes entry to the your state ledger. And another option is you would have written a very read function, right? That's a get function. When you say a get function, it'll just go to the current database. Now you can ask, tell me who is the owner of this particular syringe. Now it will go to the database. It'll say, okay, now the current owner is hospital. If the hospital has sold the injection, then it'll say the current owner is the guest, whoever consumer, whoever bought that particular syringe. And you can, after you written your smart contract, and for you to invoke through your front end application, you'll be using the SDKs. So where you will be invoking or querying your particular smart contracts. So developers create application as smart contracts. Chain codes are deployed on the network and control the state of the ledger. Application handles the user interface and submit a transaction to the network. Network emits an event on the block of transaction, allowing application to integrate with other systems. Okay, so what have we discussed? Okay, now let's understand how do you bootstrap the network. Decides on the members controlling the ordering services. So we need to have MSP configurations. You will have a root certificate. A root certificate will issue certificate to other members in the organization. And then you will have your private key, a public key, and you'll also create a admins users. And you'll create a set of policies. Policies will be like, who can do what, right? You have these many organizations here, who has which permission. And start up an orderer in configuration. You can set up the ordering services as well. Each member decides on the number of peers to participate. Okay, so in the organization, I can say I have endorsing peer, and I have committing peer, I have anchor peer, and multiple peers. At this point, we have a network of peers and orderers. Peers are not yet connected to the orderer, not to each other. So your orderers is a separate component which is running outside of your network. You can have one orderer, or you can even have multiple orderer as well. Now, if you take one example where you have only two organizations, let's say, right? In this example, let's take factory and a shipment. So what we do in that case is, so what we have peer one, we have peer two, and you create a ordering services. And the way we create a profile here is, I have a orderer. Orderer's name is orderer default, and members of this orderers is member 1 and member 2. That is organization 1 and organization 2, factory and a shipment. And in the application, we put that which are the organizations are there, member 1 and the member 2. This is a configuration file. I'll show you when you do the hands-on. You will be mentioning. If you have many organizations, you will be configuring them here. Okay, so before I go to this, let's just recall what we have seen here. We have seen the peers, endorser, committer, submitter, ledger, Chaincode event. On the ledger, we have a state database and the transaction log. And we understood about the channels. We understood about the MSP. We have certificate authority and how it issues all the certificates. And transaction flow, how things gets executed, when it is a get or when it is a delete and read. And you create a network with the two networks, what configurations you can mention. Now let's talk about more channels here. Setting up a channel, policies, and a chain code. Depending on the business network, one or more channels may be required. So that is depending upon your business. In this case, we have created a one channel between wholesaler and a hospital. We can create a one more channel between these two guys. Let me, if I were to this one, let's say a different color here. Okay, so this one is a channel 2. Okay, channel 2 between channel 2 between wholesaler and pharmacy. Okay, you can create like this, and this one is channel between these two guys. To create a channel, send the configuration transaction to the ordering service. specify members of the channel, and then the access control policies, and who are the anchor peers who receive the request. The configuration becomes part of the Genesis block of the channel. So Genesis block means the very first block you create in the Hyperledger Fabric is the Genesis block. Then notify the members to join the channel. The way it works is, first you will create your Hyperledger Fabric network, and after that you will create a channel. And once you create a channel, you will ask the organization to join the channel. Once the organization join the channel, then whatever chain code you have written, you will deploy that chain code on these channels in both all the organization which is part of the channel. Deploy chain codes on the channel with appropriate endorsement policy, or the network is ready for the transaction. So once you deployed your chain codes, then you can invoke them. Okay, so now consensus, basically you need to get the endorsement first, and the ordering, and finally your inserting, that your validation by your committing peer. So each stakeholder decides whether to accept or reject the transaction. That's your endorsement. Ordering, sorting all the transactions with the period in the block to be committer, on which order we need to store it inside. Validation, verifying whether the transaction endorsement satisfied the policy and transaction transformation is valid according to the multi-version concurrency control. So this means, because there can be n number of requests will come in, and we don't want to do a double spending. Double spending means I've already made it's like I have only 100 rupees with me, and I've given 2 check to 2 people. But only one can withdraw, but I've given the check for both of them, right? That means 2 transactions trying to modify the same content. To avoid that, that's where we create a read-write set with a version, so that we know what version has been linked for which transaction. Transaction endorsement. An endorsement is a signed response of the result of a transaction execution. So here we have seen, when the request comes, it needs to endorse. An endorsement policy encapsulates the requirement for a transaction to be accepted by the stakeholder, either explicitly or implicitly. A signature from both member 1 and a member 2 will be attached to that. Either a signature from both member or member 2 signature from this one. When you're creating your endorsement policy, you can give a configuration telling that when any request comes in, both the endorser from 2 organizations must accept it. You can give a condition like this, or you can give a condition like, when the request comes in, either of the person endorse it, that's okay. Even if one of the endorser agrees, I'm okay, I will be inserting the data. So you can do that. An endorser policy is specified during a chain code installation on the channel. Each channel chain code may have a different endorsement policy. Okay, so it differs on your business. So now here we can see that here, I have my application, I have 2 peers, okay, and I have created a channel here. So you see this channel here, and in this channel, both the peers are part of it. Only they will be able to transact, and there'll be an ordering service between these 2. Now, in this case, we have 2 members only, right? What if you want to add more organizations, right? So if I were to compare here, so you're adding some more members here, member 1, member 2, member 3. Now, these members, I can say the new member, I'm making a part of this channel. That means this new member also can see what's happening here. But whereas this member cannot see what's happening in this channel, because he doesn't have access to this. And one more thing, what I've created one more channel here. Only this organization and this organization can actually see, because this member both have a visibility. So like this, you can create multiple channels among the organizations. Whoever is part of the channel, only they will be able to see the transactions. They will be able to run the chain code. All right, okay. Now that we've understood all the components in the Hyperledger Fabric, now let's understand, we've seen this in the transaction, the Hyperledger. From a fabric point of view, kind of works similar, but let's go a little detail here. So now, from a front end, it can be anything, right? From front end, we are trying to insert some data. We're trying to execute a function in the smart contract. So we are using SDK here and we insert the data, right? Let's understand what happens here. Now, in this Fabric network, things what you see in this color, I think so it looks like orange for me or brown, I don't know. These are endorsers and they have a ledger and you have a committer here. The P3, P4 are the committers. And the green one, what you see is the ordering services. And you have your smart contracts. And each smart contracts, we have attached a endorsing policy. So now once we initiate a transaction, the transaction will go to endorser. So you have 3 endorser here, E0, E1 and E2. Now we have an endorsement policy here. We have attached an endorsement policy. So E3, E1, E2 must sign. All 3 must agree to your insertion. P3, P4 are not part of the policy, so they need not to accept it. Client application submits a transaction proposal for a chain code A. We're trying to execute a chain code A. It must target a required peer E0, E1, E2. All 3 need to accept it. And all 3 can see there is a chain code is running A and B, but whereas here A and D chain code is running. The D chain code is not here. Okay, once we send it, this endorser, they need to execute the proposal. Endorsers execute the proposal. How? E0, E1, E2 will each execute the proposed transaction. None of this executed will update the ledger. So it's just a simulation, not actual change to the ledger. Each execution will capture the set of read and a write data called as a read-write sets, which will now flow in the Fabric. So now that will retain the current state of your ledger.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
And the step 3, application receives a response. Based on the endorsement response, application will receive it. So what they'll receive? They receive the read-write set or signed by the each endorser, so that we know all the endorser are approved it. And the endorser has a signature. Again, it's a certificate authority. Yeah. And ordering transaction. Then after that, what this front-end application will do? It'll send the request to ordering services. Application submits a response for ordering. Application submits a response as a transaction to be ordered. Now it's saying, okay, I have a transaction. It got approved. Can you please go ahead and execute this particular transaction? Okay. Once the ordering service receives it, ordering happens across the Fabric in the parallel with the transaction submitted by the other application, because there can be n number of requests coming to the orderer, right? It needs to maintain the particular order here. See here, even other applications also sending the transactions. Now, after that, let's see what orderer will do here. Orderer delivers to all committing peer. You see this? The orderer will send at the same time to all the peers here. In this example, if you see, orderer is sending to organization 1 and organization 2. Similarly, if others also part of the channel, it will send it to others as well. Ordering service collects the transaction onto block of distribution to committing peer. Peers can deliver this to other peers using the gossip from peer to peer. This one. Different ordering mechanisms are available. So you can choose this ordering mechanism. For a faster one, we can use a Kafka messaging system. It will be much faster. Or then recently they have a Raft system as well, which will be much faster to send the transactions. And finally, so we have all the committing peers here. Every committing peer validates against the endorsement policy. Also check if the read-write sets are still valid on the current state, and transactions are returned to the ledger here. And they update the caching database with the validated transaction. So now your transaction has been successful and your ledger has been updated in all the organizations. So that's why we call this as a shared ledger. Once we have been updated, we need to update the client back telling, okay, your transaction is successful. So committing peer notifies the application. Applications can register to be notified when a transaction success or a fail, and when the blocks have been added. When we say that the data getting inserted, that means a new block gets created in your blockchain, which is your transaction log, and then application will get notified to here. Okay, so that's all on the Hyperledger Fabric. This just talks about Hyperledger Fabric roadmap. Hyperledger Explorer, you don't need it. It's not Hyperledger Composer. It's gone. It's a old tool. Okay, so now that we've understood about the Hyperledger Fabric architecture and things like that, now what we're going to do, we will set up our mission, to do some hands-on on Hyperledger Fabric. So I have two options here. One is if you have Ubuntu machine, we'll go ahead with Ubuntu machine. Otherwise, we can even give a try with our Windows laptop as well. All right, okay. So what we are going to do now here is all of you, please log into your Linux VM. See, what we want to do here is we will be installing a lot of components here, okay? And all of us need to be on the same page. We all need to go on the same speed. So if anyone is behind, please stop and then ask for a help so that we all have installed, all the prerequisites. Okay, so the first thing what we are going to do is we're going to install Git. Okay, so I'll give you guys this thing. Can you open terminal, please? Go ahead and start executing these commands one by one. Let me create one document. Wait a second. Open this link. In this link, I'll be putting all the commands. So we'll have to do one by one. Okay. The first command what I put there is, the reason why I'm putting it here is if you put it in a chat and we might miss it. Okay. So execute the command one by one. So that the ash, whenever I put ash, that's just a comment. So you don't need to execute with ash. Yeah, execute only those. Execute line number 2, 3, 4. Okay, I'll wait all of you to confirm me that these steps are done. Okay, how about others? Okay, good. Okay, I'm going to put the next step. So the next step, we are going to install Docker. Go ahead and install the commands one by one. It's a one full command from line number 7 to 12. It's a one command. Yeah, don't type it. You can copy paste. Yeah, please don't miss any of the steps. Do right click. Okay, see here. Installing Docker, the first command will install CA certificate, curl, and GNU-PG. Okay, then after that, we're just downloading the Docker. In third one, we're just adding some keys. And the fourth one, we're just updating the Ubuntu OS and then installing Docker C, CLI. And after that, Docker C, even Docker Community Edition, we are installing it with line number 20. Line number 20, okay? And line number 22, once the Docker is installed successfully, you'll be executing line number 22. Sudo docker run hello world. If it is successful, you will get a message telling that unable to pull the image, I'm pulling the image, and then it'll say hello from Docker. Once you get that, you're going to do the next step. The next step will be, so what we are going to do here is, you need to give a permission to Docker without running a sudo. So you're going to execute the line number 24. And after that, you need to restart your virtual machine, what Ubuntu VM you guys have. Once you restart and then log in again, you need to do the Docker run hello world. You should get the same hello world. These are the steps to install Docker. Confirm me once all of you install Docker. So whoever is done with the installation, put it in a chat. Awesome. Okay, so your Docker is installed. Execute line 24. So you see that? Hello from Docker. Okay. Now you restart your machine. You can even execute this command. I hope this command works, or you can even go and yeah. So basically, you need to restart your Linux Ubuntu machine. We've installed two things. Okay, so now let's go to the next step. Now this time, go ahead and install Eclipse. Before Eclipse, let's do one thing. Let's install Node.js. So you're getting the same error again and again. So Node is installed, yeah? Okay, good. Okay, so leave the Python part for now. May not be required, is what I guess. Let's see. Now let's install some lib tools. Okay, install this. So using Docker Compose, you will be able to run multiple containers at the same time. So execute the sudo permission. Same command. Okay, so that's not the right one. Just give me a second then. So let me change that command. Line number 2046. Instead of that, execute this command. And the 47 as well, let me change now. Just to Docker Compose version without sudo. Shouldn't be a problem. Just type Docker Compose. Docker-compose. Okay, just give me a second. Meanwhile, others, please make sure everything is installed before you go to the next step. Okay, just try to execute the same command. Otherwise, I'll have to see if is there any other option to install Ubuntu. Can install, because Python you are unable to install, yeah. So otherwise, let me get it from the official documentation. Yeah, Python is not installed. So you have Python 3 installed. Okay. Then in that case, try execute pip command. Okay, wait a second. Only thing is the version will not match. Okay, that's what the Python pip3 is not installed, right? That's why. You'll have to install pip3 first then. Okay, so now everything is installed in your case. Just verify from beginning. So you have Docker installed, Python installed, Node.js installed, Docker Compose is installed, libtool is installed. Okay, all right, okay, all good. How about others? All right, okay, so now we have installed all of this. Now let's download the libraries, okay? So Hyperledger Fabric libraries. Okay, I'll tell you what you need to do. If this works fine, that means your installation is successful. Okay, so let me put the next step here. Download Fabric libraries, okay? Okay, execute this command. So in this version, we are downloading Fabric 2.2.2 and then Fabric Certificate Authority 1.4.9. Okay, awesome. So if all of you got output like him, that means your installation is successful. Others, please confirm if everything is okay. You see this? It has downloaded all the Docker images required for our Fabric. All right, okay. So now let's move on to the next step. Okay, so now go ahead and install VS Code. I'll explain you later what you're doing. Just follow along this tutorial and then install it. I mean, official documentation. Okay, so if you already have Visual Studio Code is installed, then okay, I see in your case it's already installed. Yeah. Open that Visual Studio Code. Okay. Have you installed that? Okay, yeah. Okay, in your case it's installed. I'll just wait for others. Okay, good. Okay. So if everyone already have this VS Code, that's really good. Okay, the next step is Now that we have our Hyperledger Fabric libraries installed, and then VS Code is also installed. Now let's go ahead and configure some more things here. Okay, just execute this command on this Docker. Execute line number 62. Okay. Now once you restart your VM, then we will next step we will install all the Java related components. Okay. All right. Okay. So the next thing what we are going to do here is let's install Java JDK. Let's just check your version, Java version. Okay. Now go ahead and install JDK. Okay. I see that you have installed it. Others, please confirm me if Java is installed, the JDK is installed. Okay, so now that we have Java installed, now go ahead and install Eclipse. Go to their website and then you can install it. Eclipse, just download Eclipse and install. Okay, good. So now Eclipse is also installed. Okay, so now we're going to do two things here. Okay, one is so basically three things, right? When we talked about the architecture, which we explained yesterday. So you have your Hyperledger Fabric network, and then you will be writing your Chaincode. Then you'll be writing your SDK to talk to the Chaincode. So to write a Chaincode, we'll be using Gradle. Okay. So now let's go ahead and install Gradle. So similarly, like you guys did, just find in the internet and then install Gradle. Latest version should be okay, I guess. So like 7.0. So just do Gradle-v, see whether you're able to see the output. That means the Gradle is not installed. Okay, I see that in your case Gradle is installed. Others, just please verify if Gradle is installed in your case. Okay, cool. So, okay, all right. So now that you've created, let's link this your Eclipse to your Gradle. Okay. Now open your Eclipse. Search for Eclipse. The installed. Yeah. Okay, make it a full screen, and select the default workspace, whatever it selects. Okay, good. Now in here, from the top menu option, select help. Yep, select help. In here, go to Eclipse Marketplace, and here you search for Gradle. So here you see the third option, build ship Gradle integration. Okay, so that should be installed. Okay, that says installed. Okay, good. Now we have downloaded all the components required to build our network, and we've also installed all the required things to build our Chaincode. And Maven also, I'm sure that would have been already installed to build our front end as well. Okay, so now I'll talk about these things now. See, when you downloaded this one, when you downloaded, what do you say, Fabric library, right? You will see a folder called as Fabric samples got downloaded. Can you open that folder? Okay, you will see this Fabric sample folder in your home directory itself when you downloaded all the libraries. Do you see that? Yep. Okay. Now open this folder in your VS Code. Just say File, Open Folder, and then select that folder. Okay. Hope you open this. So what we have here in this file is under fabric.samples, we have a folder called as a pin. Okay, so these are the actual libraries which we will be using it, when you're running your network. Under pin, we can see that config gen tool. Config gen tool is used to generate all the setting up the network. Okay, we need here in this example, we're gonna set up two organization network. Okay, so we will be having a two organization. In each organization, you'll be having a peer, and then you'll also have a couch DB as a database. That's what we're going to set up network now. And we have a config tx later that's related to the same network thing, which will create which will create your Genesis block. Genesis block is the first block. Okay, and then we have a cryptogen. Cryptogen is used to generate all the crypto materials like your MSP, your private key, public key, signatures, and things like that. And you also have a discovery. That's like a works like a discovery file, service discovery, checks all other services. Fabric's CA client. This is a certificate authority for the client, and then certificate authority for servers. So similarly, this we have some more things. This for ledger creation. Okay, this is for orderer. We know orderer, and then another library to run our peer. Okay, that's your main folder. Otherwise, what Fabric samples folder has is they have created a lot of sample chain codes, which we'll be exploring. So they have folders like the chain codes folder. If you explore the chain code folder, now they have so many sample projects they have created: AB Store, Fabcar, Marbles, and then some more. Now, when you expand chain code Fabcar, so there's a program written for multiple languages like Go language and Java language and JavaScript and TypeScript. Whichever you're interested, you can take a look at it, but we'll be learning majorly on the Java here. But we'll not go to this chain code yet. Okay, first we will talk about the network. And otherwise, we have whatever project we're talking about, the complete project details. SDK will be here. So if I take asset transfer for the chain code Go language, they've added here. Okay. Similar asset transfer basics, asset transfer. If we go to Java, okay, now SDK is here actually. Yeah, if you see this one, this is the code available in here, and this code is available under the chain code. Okay, wherever you see chain code folder, that code is available. Okay, now Fabcar is a very big project, and here we have Java code as well. This is your SDK. How are you going to access from here? And see here, we are going to use a Maven for this one. You can either use a Maven or a Gradle, but we are using Maven for the SDK development. We'll go little detail in all of this. Okay. And then what folders I want to talk about? Not this one, script, test application. Okay. The important thing is the test network folder. So open this test network folder. This is where this is the folder which we will be using heavily to build our network. So now things what we have here is we have one important file called as a network.sh. Just open this file. Apart from this, we have a lot of files here which we will be referring from the network.sh file. All these are shell scripts. You can see here to create a channel, we have all the channel artifacts file here. To create a network, we have a network file here. To run our network, all the Docker Compose files are present here. To set up organization, we have the crypto gen tool, which will generate all the certificates and Fabric certificate for every orderer organization. For every organization also, we have all the crypto materials here. Some configurations we'll be doing here. Okay, so that's under organization. Under scripts, we have some more scripts like create channel, configuration update, deploy chain code, set environmental variable, some utilities, or set anchor peer. Some configurations are available here on the script folder. Just as a Genesis block configuration. Okay, then this is just going to store all the logs if something fails or something. Okay. All right. Okay, let's first explore the network.sh file. This is a very important file. We'll be using this file heavily to run our network. This script brings up Hyperledger Fabric network for testing smart contracts and applications. The test network consists of two organizations with one peer each. So what it's going to do, it's going to create a two organization, and then in each of the organization, there will be one peer will be running. And a single node raft ordering service. Okay, so it also has a orderer node, which is a raft ordering services. Much better than your Kafka. Users can also use this script to create a channel to deploy the chain code on the channel. Okay, so now what you're going to do, first you're going to build this network with two organizations and two peer, one peer in each of the organization. And once the network is up and running, then we're going to create a channel within that network. And we'll be using the same file. We just need to pass the additional parameters. What we are doing, So basically I will just appending this present working directory to the bin path to ensure that we are picking the correct binaries. So whatever this bin folder you see, that's a very important folder. So we're just adding that into the current path. Okay. And Fabric configuration, file configuration, you're setting it, and then some other settings we're doing. You're just executing some utilities file here. And after that, before even we run any Docker containers, we want to make sure just clear some of the older containers running. Okay, because everything is a Docker container here. So if you remember when you did a Docker ls, you saw all the Fabric network components are running as a Docker containers, right? We're just clearing all of them here. Remove unwanted Docker images, any older versions of Docker images of Fabric, we're just removing it in this code. All right, okay, and then here we're checking whether if all the prerequisites have been installed. So if the libraries have been downloaded and if all the test network configuration files have been downloaded, it'll check everything. Do some basic sanity checking to make sure the appropriate version of Fabric binaries images are available. Additional checking also will be available here. Okay, all right. And use a Fabric tool container to see if the example binaries. Okay, setting some Docker image version. You can run different versions of your Hyperledger Fabric, right? The one what we are running is 2.2.2, I guess, yeah. So we'll be running passing that image ID. If you're running a different version, you'll be changing this image tag. So that's how Docker works. So Docker will have an image name and there'll be a different version. So just to understand this, you're working on a project 1, and this week you did a one release, then your version will be 1.0.0. Next week you're doing another release, you'll have project 1 colon 2.0.0. So like that, that's your version number. Okay, we're setting up some Docker version numbers here. Okay, and now we are checking now. We need to issue the Fabric certificates, right? So further, we're just checking if all the binaries have been downloaded for the certificate. Okay, and then before you bring up a network, each organization need to generate the crypto material. Yeah, that will define that organization on the network. Because Hyperledger Fabric is a permissioned blockchain, each node and a user on the network needs to use a certificate. So that means every Docker container and then every user admin whoever logs in, they all need to have a certificates. So in addition, each user needs to belong to an organization that is recognized as a member of the network. The users also need to be part of the organization. You can use CryptoGen tool or a Fabric certificate authority to generate the organization. So we'll be using CryptoGen tool. By default, a sample network uses the CryptoGen. CryptoGen is a tool that is meant for development and testing that can quickly create your certificates and a keys that can be consumed by your Fabric network. So all the network will be created by CryptoGen. The CryptoGen deal consumes a series of configuration files for each organization in the organization/CryptoGen directory. Here you see this in the organization folder. You have all the crypto materials available here, the CryptoGen. So this is the configuration we mentioned. I'll come to that file. You can also ask Fabric CA to generate it, but anyhow, we're going to use a CryptoGen. So create organizations, CryptoGen material using the CryptoGen. So create organizations. Okay, so now we just deleting something if the folder is not available. Now what we are telling, okay, use a CryptoGen tool. Okay, so the one you use it, using something here, yeah, we use this command, CryptoGen generate and give the configuration file. This is your master or a root certificate key. With that, you'll be creating for the organization. Then it will say creating organization to identity. It's creating for org1, then it is creating for the org2 because you're creating a network with the 2 organizations. And finally, you're creating orderer identity as well. Okay, so using the same command, crypto generate. So now the way we configure here is, if you go to test network under organizations, CryptoGen, we have 3 configuration files here. So one file for the orderer. So what we are telling here, definition of organizations managing orderer node. See, orderer organization, the name of that orderer is orderer and the domain is example.com. Enable node is to some settings here, and then the host name is also orderer. It's running on localhost. Similarly, we'll do a configuration for our org1. For the org1 peer organization name is, the first organization name is org1, org.example.com. Okay, there's some more settings also which you can actually do, which is commented here. You can set up a different host name, common name, and other things. You can even set up some templates as well here. Now I'm telling count is equal to 1. That means just create a 1 peer. Okay, in this example, if you want more peers in any organization, you will increase this particular number. And here, how many users we want to create it. Okay, by default, we'll create one admin and then one user. Similar configuration for the organization here. Okay, same configuration. All right, so that's your CryptoGen tool. Similarly, we have, if you're running on the Fabric certificate authority, we have the similar configuration. So for the Fabric certificate, you'll do the configuration, telling that this configuration file for the Fabric certificate server. Just give me a second, guys. Okay, this is all Fabric certificate. Similar to that, we're just saying, okay, do we need to enable the TLS, and where will the certificate files will be downloaded, and what is that certificate authority we are using, what's the TLS, how long it's going to expire, all other detail. We're not doing with the certificate authority, not going through this, but this is all the configuration for every organization here. Okay, that's a Fabric CA here. Now let's go back to network.sh. So now as a first step, what it does to bring up the network, it makes sure that all the Docker containers are running. And then the next step is it creates all the crypto material for orderer, org1, and the org2. Now we can see that generating orderer org identity, creating org2 identities, and then creating the org1 identity. Okay. So once that's being done, this is a certificate authority. Moving on from there.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Once you create organization crypto material, you need to create the Genesis block of the orderer. All right, good. So now we have seen this crypto materials gets generated. Okay. After that, let's see what happens. Once you create crypto materials, you need to create the Genesis block. That is nothing but your first block in your blockchain. Genesis block of the orderer system channel. This block is required to bring up any orderer node and create any applications in the channel. Okay, so it's going to bring up the orderer node. And we're going to use this config.tx gen tool. Is used to create a Genesis block. Config.tx gen consumes a file called as a config.tx.yaml file that contains the definition for the sample network. The Genesis block is defined using 2 org orderer Genesis. Like we're using 2 organization, 1 orderer. That's a Genesis block. Profile at the bottom of the file. And this is called as a profile file. This profile defines a sample consortium. That means it's your network consisting of 2 peer organization, right? org1, org2. This consortium defines which organizations are recognized as a member of the network, right? We're going to have member 1, member 2. That is org1 and org. The peer and the ordering organization are defined in the profiles section at the bottom of the file. As part of each organization profile, the file points to the location of the MSP directory for each member. So whatever the crypto material we generated in the previous step, we will be referring those crypto material when we are bringing up our network. The file points to the location of the MSP directory. This MSP is used to create the channel MSP that defines the root of a trust for each organization. So you'll be using that root certificates to generate other certificates, right? We need to mention that URL as well. In essence, the channel MSP allows the node and user to be recognized as a network member. The file also specifies the anchor peer. Anchor peer is the peer which first receives from orderer for each peer organization. In future steps, the same file used to create the channel creation transaction and the anchor peer upgrade. All right. Okay. So now let's take a look at this file, config.tx.yaml. Okay. So under config.tx folder, you will see config.tx.yaml file. This section defines the different organization identities, which will be referred later in the configuration file. So main and whatever you see is a YAML configuration. Okay, YAML is very simple. If you guys don't know YAML, the way we write YAML is it's like key and a value here, like this key and a value. Now let me take one example here. So I want to add a name. Okay, so I'll use a name is Arjun. Okay, key and a value. Now, for example, I want to put the details. That means I'm gonna have parent and then multiple child. In that case, what I'll do, I'll just put this and I use a two spaces. Two space, then I'll say name is equal to Arjun. Okay, I'll say the technology, what he knows is the blockchain. Whenever you have parent and a child relationship, you give a close spaces. Now take another example where you have multiple employees. Then you'll use one more thing called as, for example, I have employees. I'm defining first employee, array of employees, right? Two space, hyphen, one space, and then the employee name. So employee name is Arjun. You can have any key, any value, you can put any random, doesn't matter. So the technology, what he knows is this one. Okay. And I have another employee, then I use another hyphen here. Okay. Now this will be treated as an array. Now I have another employee. Okay. Now other employee is, let's say, Mangesh. Okay. I'll just put this thing, and then what the tech he knows, let's say, he's good at cloud, let's say, right? So we're going to do something like this. So when you have multiple, then you'll keep on adding multiple hyphens here. That's it. Very simple when you're writing a YAML file. So that's what we have done here. So we're creating a parent organization. We use a colon here. We've given two spaces, and then since we're having multiple organizations here, we are putting the hyphen here. Okay. So now sample org defines an MSP using the sample configuration. It should never be used in a production, but may be used in a template for the identities definitions. Orderer org, that's a name what we are giving. And default org defines the organization, which is used for the sample configuration. Orderer organization is the name we are giving. And the MSP name will be orderer MSP. And where is that MSP directory? All your certificates is available in the organizations, order organization, example.com, MSP. Okay, so let's go to that folder, organizations. Okay, and order organization, and you can see that here you have a MSP. In the MSP, you can see that here you have admin certificate, you have CA certificate, you have TLS certificate. All these things will get generated when we run our network. And then you have a config.yaml file to define your certificates. So where is your certificate needs to be generated? What is the name of the certificate? All the configurations present here. And similar configuration we have for others as well. Okay, so now order configuration for peer organization as well. For peer organization, org1.example. So we have a certificate authority, we have MSP, we have all the peers and all the TLS certificates and all the users one. Okay, and the certificate authority, you can see that the private key is available here, and MSP, admin certificate, CS certificate, and TLS certificate in the same configuration. And the peers, peers 0, org1, MSP, and the TLS, and then the users. We're going to create two users. One is the admin user, another one is the user 1. Because in the config.tx YAML file, if you remember, we mentioned you need a 1. The count was 1. The previous configuration we did. All right. Okay. That's on the organization, on the peer organization. Okay. So now let's go back to, I'm going to close these files and just close all the files. Okay, so now we mentioned where is our MSP directory, and then we're going to set some policies like, your policies like what kind of access they have, what policies we are setting for each organization. So policies will be, you can set up a reader and a writer and then the admin. They're saying that orderer MSP has a reader permission, write permission, and then also admin permission. And each of these nodes will be running on a particular port. This is very important. Whenever you are referring to orderer node, you'll be referring it as hostname will be orderer.example.com and 7050. That is the port on which your orderer runs. Now we're going to configure for org1. For the org1, we're mentioning where is the org1, all the MSP materials available, the same URL, and mention all the policies here. And then similarly for org2, where the MSPs and then policies, reader, writer, admin, and endorsement also we are enabling. Okay, they are the endorsement policy. We're adding it for both. Any request comes in, both endorser, org1 or org2 should be endorse it. Okay, that's the thing. And otherwise, you can put a lot more profile information like capabilities we call. So this section defines a capability of Fabric network. It's a new concepts. Should not utilize the mixed network, the older version if you're running it, the older version, because this is running on v2.0 or 2.2.0. Capabilities define feature which must present in the Fabric binary for the binary to safely participate in the Fabric network. If a new MSP's type is loaded, the new binary is recognized. Okay, that's fine. Some capabilities what we can add. So we are applying the capabilities to peers in the order channel capability, which version we are setting it up, and for the application level, what capabilities, what they can actually do. Okay, on the application level also, we are setting up some rules, what they can actually do, what they cannot do, and things like that. And this is on the orderer. Orderer, we are using a Raft orderer node. That's the name what we are giving here. And order is running on 7050. And the Raft node is running on, this is certificate we are mentioning, client certificate and the server certificate here. And what is the timeout we are mentioning here, and how many blocks it can actually create in a few seconds, right? These configurations we are making here. Okay, so batch size controls the number of messages batched into a block. How many messages you can put in a one block. Maximum message count, the maximum number of messages to permit in a one particular batch. Absolute byte, what's the size of the block? And predefined max byte, what's the maximum size of any block? Similarly, for the organization also, you can make the same configurations here. Okay, policies. And then comes to channel. Okay, so since once you have your crypto material ready, once you have your network, all the peers are ready, then we're going to create a channel configurations, right? This section defines a value to encode info into the configuration transaction and the channel related parameters. So we say channel's default. What is the policies we are mentioning here? The reader, writer, and admin. And same like we have done above, add all the capabilities like profiles, what are the application level capabilities, and finally you just add a profiles here. So the profile what we are going to use here is to orderer genesis, and the orderer node is orderer default, organizations, order, whatever you're configured at the top, we're going to call them here. Okay, and a consortium, we're calling it as a sample consortium. In our consortium network, we are having two organizations, that's org1 and org2. Okay, that's the same config. Whatever you defined here, finally, this is our profile. Your network will have one orderer and two organizations. Okay, now let's go back to network.sh. Okay, so now what we're going to do, we're going to generate the create consortium. This will create your Genesis block. So we're going to use a config tx gen tool. Okay, so it will use, this is the command what it will use, config tx gen, and the profile whatever we created a profile called as a to org order genesis, right? That's a name we have given. It's going to take this profile. And channel ID, the system channel what you're giving, then output where it needs to create the Genesis block will be created like this. System Genesis block folder, Genesis dot block, it will get created. Okay, if something goes wrong, it will say it's unable to create it. Okay, and after we create org crypto material and the system channel Genesis block, so we have created a crypto material and our Genesis block is also created. Now we can now bring up the network with the peers and the ordering services. By default, the base file for creating the network is a Docker compose test not file. Okay, Docker, this file defines the environment variables and mount if you are using anything. So now we need to bring up our network. So to bring up a network, we'll just check prerequisites like either we have downloaded all the libraries, whether we have all the crypto materials ready, whether we have our Genesis block is ready. And once that's being done, then it will create an organization, create a consortium. There are both steps it's going to create it. And after that, it's going to execute the Docker compose file. Okay, so if you see here, it's going to execute like Docker compose and then the compose file. Now, if you see here, the compose file we have mentioned at the top, with the Docker compose file. Okay, so Docker compose file, FNCA. Yeah, I can see that here. All the files are present in the Docker/Docker compose test network. The files we have, use this as a default Docker compose YAML file. If you want to run as a CouchDB as your database, then you will use Docker compose couchdb.yaml file. If you want to use a certificate authority, you'll use Docker compose -ca. If you want to run R3 also to add, then you'll be using this one. Okay. Otherwise, we have this. Okay. All right. So now we'll go to the Docker compose. So you open the Docker folder. You see the Docker compose. Let's open this testnet folder file. There's a lot of files in here. I encourage you guys after the training, just go through these steps once again, so you'll understand better. Okay, so Docker compose means very simple. If you have one container, and if you want to run, if you have one Docker image, and if you want to run that, you can just say Docker container run and the image name, it will run. But when you have like many Docker images for you to run, instead of executing all the run command manually, you can write everything in the Docker compose file. It will run n number of containers at one shot. Okay, that's the use of Docker compose. Now here what we are telling, so we're going to run many Docker images. So in Docker, we have a concept called as a volume. Volume means the way Docker works is whenever you run a Docker container, if the Docker container is saving some data inside the container, then when you delete the container, you will lose the data stored inside the container. So for that reason, what we do, whenever you run a Docker container, and if you have any state information or if you want to store any data like MySQL, you will store outside of the Docker container so that even if the Docker container is deleted, your data will not be deleted. For that reason, we use a volume. So now we are creating a 3 volume so that all the information will be stored in this volume. So that even if Docker container is deleted, your data is still present. So you're creating a 3 volumes. And within the Docker, we also have a networks. Network means having a private IP addresses and then having a slider block, right? You will be creating a network. So you're creating a separate network in the Docker called as a fabric_test. So all your Docker containers will be running inside this Docker network. That means every container will get a separate private IP address. And what all we are running? We are running order.example.com container. We are running peer0org1.example container, peer0org2.example container. We are running CLI container. Okay. We'll be running 4 containers. So let's explore order.example.com. This is the name of the container. The container name is order.example.com and the image it's going to pull from the Hyperledger Fabric.orderer. So what this will do, it will go to Docker Hub, Hyperledger, and it will pull this Fabric orderer latest version or 2.2, whatever version we have pulled. And we're just passing some environmental variables, setting up on which port it needs to run, where is the Genesis file, where is the orderer MSP, on which port it will be running, do we enable TLS, where are the certificate authority, and other detail, which is the working directory. And the command will be orderer. That means once this container is running, if you type orderer, you can execute command inside this container. Then you're defining the volume here. Whatever the volume you have created at the top here, you're telling use this particular volume for this container. And it will be running on the 7050 is the port which order runs. There's one more port also we are using. And what network it needs to? It needs to use this test network, what you have created. Okay, now this is going to create a orderer container. Similarly, we have peer0 org1 dot container. The container name is this, and it's going to pull this image called as fabric-peer. Similar to that, we're just passing all the environment variables. Here, what we have seen, your orderer runs on 7050 port number. But whereas your peer0 runs on 7051. Okay. And we're just mentioning where is my certificate, where is my key. We've enabled the Docker, and what is the ID? Peer0 org1. Okay, .example.com. And same like before, we're setting up the volume, and the command is peer node start. This is a command, we'll be using it, running on the same network. Similarly, what we have, so we have a peer0 for org2. Okay, so when you create a one more peer in any organization, it will be like peer1.org1, peer1.org2, it will be like that. Okay, we are running another peer for the organization 2, same like the above one. Only thing is your organization's 2 peer will be running on 9051. So 9051, 7051, and 7050. These are the 3 main ports we'll be using it. Finally, we have a CLI container. This is basically our Fabric tools container. Okay, so now command is just going to the bash and depends on both the peers. Both the peers need to be up and running. Okay, just setting up some Go path in here. Okay, all right. We have not installed Go, but let's see if it required, we'll install. All right, okay. So now let's continue our network.sh file. We've seen create organization. Okay, we're talking about the network up. Okay, when the network up, it's going to bring up all the Docker containers. Then it'll say unable to start. Then once a Docker container is ready, it will say your container is ready, and then all the network is up. All right, okay. And after that, the next step is we will be creating a channel here. Okay, once the network is ready, we need to create a channel. Okay, before we go to create channel and then the deploy chain code and functions here, first let's execute this command to bring up our network. Okay, so let's see whether our network is coming up or not. We'll execute till here. Okay, now go to your terminal. Do one thing, open VS Code. Okay, in the VS Code, can you open the terminal? Okay, so you are under the Fabric samples folder. Can you cd into test-network folder? Yeah, just type that command cd. Yeah, that's right. Yeah, that folder. Yeah. No. CD space test-network folder. Yeah. Hit tab button, it will automatically fill. Okay, so now you are inside that particular folder. Now what we are going to do here is, before we bring up the network, so let's execute that command once again. Can you go to that code share? Okay, copy that line 61. Now cd, no, don't execute here. Go to the home directory here. Use VS Code only. You can close the terminal. Go to the home directory, like cd dot twice you do, or cd tilde also you can do. Yep. Okay. Now you execute that command here. Love you. So please do this in the home directory. Okay, not in the test network. Okay. All right. All good. I'll just wait others to confirm me. Okay. Great. Okay. Cool. Now cd into the test network folder. Fabric samples in the test network. Okay. Great. Now let me put this code in our code share. So bring up the network. Let's see if we have done everything rightly. Your network should be up. I'll explain you what is happening here. Lovely. Okay, now can you maximize that? I'll just explain. And then remove this Explorer button also at the top left. So that the window will be big. Yeah. Okay, now go to the top. Okay, now one second. Yeah. Okay, now stop. Yeah. Okay, so now don't mouse or anything. I'll explain from beginning. Okay, now what we have done here, starting a node with a CLI, timeout 5 tries, CLI delay 3 seconds, and then using a database level DB. By default, it uses a level DB, but for the next steps, I'll show you how do you run this with a CouchDB, with a crypto using CryptoGen. In the local version 2.2 Docker image version, what we are using is a 2.2.2. Okay. And then if you see here, next step, what it is doing, generating the certificate using the CryptoGen tool, which we have already discussed. Yeah. So what it does, first thing, creating a org1 identity, and the command what it has used. Can you highlight whenever I'm talking? Okay. Yeah. So CryptoGen generate, and then we are giving the configuration for the org1, and it creates a crypto material for org1. Yeah. Okay. Now the second step, yep, that's right. Second step, creating org2 identities as well, similar to the above one, but this time we're just referring to crypto-config-org2.yaml file. Yeah, so that's the command. All right. So creating org2 is also done. And third step, creating orderer organization identities. Okay, so all the crypto materials have been created in that particular folder. Next thing is now creating a profile. CCP means connection profile files for org1 and org2. So where is it creating? Fabric sample, test network, and bin, and then the config.dsgen. All right. Okay. And then as we have seen, now next thing is once the crypto metal is created, we need to create the Genesis block. Yeah. And we are using the profile as a 2org order Genesis. That's the profile name what we have given. So if you see here, based on that, what it has done, it has gone to that config.txgen file, and it's loading the configuration, and it's using the raft as your orderer. Yeah, that's your order as a raft. And then internal election snapshot. Okay, looks like everything is fine. Loading the configuration, loaded config text. Yeah, now generating the Genesis block. Okay, that got created. Okay, writing the Genesis block. All right, awesome. Now after that, creating the network fabric test which is creating. That's a test network what we are creating it. Creating the order.example.com. These are the containers what it's creating now. Okay, the order.example.com is a first container. And the one you highlighted now, that is a peer 0 org2.example.com. That's the org2's peer is created. And next one is org1's peer is also created. And then finally the CLI is also created. Okay. Now you just do Docker container ls. Can you do control minus? So the screen is small, still small. Okay, yeah, still small. Okay, now you do Docker container ls. Type Docker space container space ls. Are you typing? I lost you. Yeah, Docker container ls. Yes. Enter. Okay, there you go. So now you can see here our network is running. The first container ID, Hyperledger Fabric tools is running. Okay. And just 4 minutes, just now you ran. Yep, that's right. And then the second container, Hyperledger Fabric peer is also running. And the peer node start is what we're going to give. And if you scroll to the right on the port number, you see the first, that's running on the 9051, right? That is your peer 0 or 2. Okay, peer 0 or 2. Similarly, we are running the fabric peer that is running on the peer 0 org1.example. Yeah, like you highlighted, that's running on the 7051. Very good. Okay. Yeah, that's 7051. And then finally, our orderer also is running. Order is running on the 7050. Awesome. Now go back to your VS Code, in the sense Explorer folder file Explorer, and see all the crypto material generated in there under test network, organization, peer, the one which I showed you. See those folders. You can do control tilde, it will go off. You can even do click wrong button there. You have a wrong button there on the top right. Yeah, click that. Yeah. Scroll down. In this, you open that. Organizations. Okay. Yeah, open that. Peer organization. Okay. Order1.org example. Yeah. So explore all of this folder. MSP, open that MSP folder. Okay. Admin certificate. Click on that admin certificate folder. No. Yeah. CA certificate. Okay. Got created. TLS got created. Peers. Click on open the peers. Okay. Peer 0. Yeah. I can see admin certificate. CA certificate. Okay. Yeah. Key stores. Everything got created now. Nice. Okay. All right. All good. Okay. Okay. So now that what we have here is we have done our network. Okay. So network is up. And anytime when you want to bring your network down, we're going to do something like this. Dot network.sh dot down is what we're going to do to bring the network down. So tomorrow when we do it, first we will bring the network down and then we will bring it up so that it will delete all the previously created containers. Okay. So now what I want to explain you. Okay, let me explain you this. Okay, now what we have seen here, our network is up and all the Docker containers are running. So we saw orderer, we saw the CLI, we saw peer 0, org1, peer 0, org. Lovely. Now once that's been created, the next step is we're going to create a channel. So now call the scripts to create a channel and join the peer of org1 and org2. And then update the anchor peers in the each organization. So first thing we're going to call this create channel. So we have this create channel file. Now run the script that creates a channel. This script uses a crypto tx gen once more because we use the same thing to generate our Genesis block as well to create the channel creation transaction and the anchor peer updates. The config txt YAML is mounted in the CLI container, which allows us to use it to as a create a channel. Okay. So now let's open this create channel. And the channel name, we will be giving it as a my channel or something. Okay, by default, we are giving this name.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Sorry, yeah. Okay, so now channel name we have given here. So let's check the channel name. Okay. By channel name, by default, we have given the value as a my channel. If you want to change the channel name, we can come here and change it, or you can even pass it as a parameter when you're running the shell script file. So I'll explain this create channel file. So if you open scripts and then we have create channel file, everything is a shell script again. Okay. So we're just importing some environmental variables here. Under environment variables, if you go here, we're just setting up where is the orderer certificate authority, where's the peer order certificate authority, setting up some export variables. Okay, all the variables. So create channel, channel name. So whatever the first variable we are passing, that's the my channel. Okay, all right, and create channel transaction, and it's going to use the same thing, config tx gen tool, and profile is to org channel. Okay, that's the name what we're giving, and the output will be generated in this particular file, and there'll be a channel ID, which is nothing but a my channel. It's going to pick it up. Okay, and the way it's going to do here is setting up some variables here. It's going to use this command, peer channel. That's a command it's going to use. Peer channel create on this particular orderer, which is running on 7050, and the channel name is -c. That's a my channel, and the orderer TLS name is this one, and all the artifact is present in this particular folder, and the output block will be created here, and the TLS file, and where the orderer certificate authority, where is it present, and it's just going to print it output into log.txt file. And after that, the channel gets created here. This is the only command it's going to execute. Once a channel is created, And after that, what we need to do, we need to join this channel, right? If you remember this, we first create a channel, and then where org1 and org2 will join the channel. So the next command is join the channel. Okay, so setting up some variables. All right, so what we are telling, we'll be doing it for both the organization. So we'll do it for org1 first. Peer, channel, join the block file, whatever you're telling, and it's going to join the org1. Then again, it will loop again, and then it will join the org2 as well. Okay, so both org1 and org2, we're telling it right while we're doing a looping here. So it will join both the organization to put that particular channel. And after that, we're just setting up the anchor peer, which is nothing but our first peer will be setting as a anchor peer. Okay, and after that, we're just setting up some variables, create a channel transaction. Okay, and creating a channel, the same thing, we're going to call this command again. Create a channel will be called here. This will be called. And after that, since we have two organization, we'll be calling join channel for org1 and joining channel for org2. Okay, and after that, set anchor peer for org1, set anchor peer for org2. All right, so that's what we're going to do. Okay, let me put that in the code share. Create channel. Okay, use this command. If this fails, then we'll bring the network down and then we'll execute that. You go to, wait, go to test network folder and then execute this. Because that's where the file is present, yeah. Okay, channel creation is failed. Now bring down the network and then we'll do that again. That might fail, but let's see if this works. Otherwise, because you need to have a network created. Okay, try executing that command. Let's see what happened, the 85 command. Awesome, lovely. Okay, now can you zoom everything? I'll just explain things. Okay, go to the top. No, zoom out. Sorry, what do you call zoom in? Zoom out, yeah. Okay, yeah, enough. Go up, go to the top. Go to the top still. Okay, scroll down. Yeah, okay. See now here, what it has done here is, whatever is done in the previous step, it created that and then it created this also, okay. I'm going to go fast here. Creating org1 identities, creating org2 identities, creating orderer identities, creating a CCP profile is done. Scroll down. Yeah. And then you can see all the 4 Docker containers also running. Yeah. Nice. So this is what we have done the previous step. So far. Yeah, that's right. Yeah. And now what it is doing, now it is creating the channel, generating a channel, create transaction. So now we can see that it created the channel ID and then writing the new transactions, and it's using that command. You can see peer channel create and then particular thing. Okay, all right. Endorser also configure. See what our configure set. Endorser order connection is initialized. Something it's telling. Okay, fine. Scroll down, and then finally you can see channel. My channel got created. Okay, that's a name by default. It's mentioned in the .network.sh file. Okay, channel got created now. And after that, we need to join the org1 peer channel join with the block name. Okay. Then joining org2. Okay, we're doing the join org2 using a similar command here, and switching the configuration. Yep. Okay. Scroll down. Generating, and then it's also after joining, it's create an anchor peer as well, right? So you can see that anchor peer is also doing it. Okay. Okay. Scroll down, please. Okay, I can see anchor peer set for org1 channel. Okay, and the main channel setting up for the org2. The next step it's doing for org2. We're doing repeating the same thing for org2. All right, scroll down. Yeah, generating anchor peer. Yeah, that's right. Okay. Now, awesome. Anchor peer set for org2 as a channel is done, and the my channel is also joined. Lovely. All right. Okay. So then once we have pulled that, we installed VS Code. We've installed Java JDK, we installed Eclipse, we've installed Gradle. All right, okay. And after that, what we have done, we've gone through .network.sh. So this is a very important file. This is the file which will help us to create all the crypto materials, create the network, and create the channel as well. So now the steps what we have done here is, let me just put it here. Then we'll go through this files here. Okay, first is bring up the network. Okay, so in that step, what we also do, create all the crypto material, all the secret keys and everything, right? And then what we did, then create channel. So if you remember in yesterday's last exercise, we created a channel called as a my channel. Then after that, what we are going to do here is develop Chaincode. And after that, now you need to deploy Chaincode. And finally, you can access Chaincode. That's what the step is. And finally, to access everything, what we can do, you can use a Fabric SDK to access, like from UI or API, like this you see in the diagram down. Today, we'll learn about this Chaincode. All right, okay. Just give me a second. Okay, all right. So now, let's talk about this Chaincode. Okay, so can somebody tell me what do you mean by smart contract? Yeah. All right. So basically, all your business logics, you'll be writing it through that. Is that's what you meant? Yeah. See, now when we talk about a chain code, and by the way, chain code and smart contract are same. In Ethereum world, we use smart contract as a word, and then but in the Hyperledger Fabric world, so we just use chain code. But it is same. It is still smart contract only. What we are referring to. There's no difference. Okay, so now let's talk about this. See, when we talk about chain code, there is a life cycle actually. Okay, so we call it as a chain code life cycle. The chain code life cycle, there are steps involved in developing the chain code. So let me put all the steps here. First thing what you need to do is you need to develop the chain code. We will be doing that today. Fabric as this Fabric API. Using that API, you will be able to develop your chain code. So basically, chain code means you take any example, the actual business logic, actual the crux of the particular project, right? That will be written in the program. Same like any other language, but the main business logic will be written here. So in the chain code, if you compare with any other Java or any other regular classes, so it will have properties and it will have methods, no difference at all. So those methods or functions, whatever you call it as, those are the things which will modify your database, modify your ledger. Okay, that's our smart contract. So we first need to develop the chain code. Once you develop the chain code, the next step is we need to package the chain code. The package the chain code means what are the chain code we have developed, that particular chain code, we need to zip it in a particular format. Okay, so that's called packaging the chain code. And the third step is installation. So the chain code what we have packaged here, the step 2, these chain code must be installed in all the peers in the your network. But in some cases it may not be always true, because in your network, if you have multiple channels, and then because you will be deploying this chain code in the channel, so whoever is part of the channel, only on those organization we need to install it. And smart contract or a chain code is considering this is a business logic, right? And that's going to modify the data. We cannot blindly install any program in the network. Whatever program we write, whatever smart contract we write, that needs to be approved from all the organizations. So the next step is the approval process. Approval has to be done from each organization. And finally, once it is approved, then we need to commit this particular chain code onto the organization. Okay, so this is what the high level steps are. And with respect to the languages, chain code you can develop in multiple language. So you can either use Golang, or you can use Java, and you can use Node.js. So the concepts and everything is similar across, you choose any language. Only thing is the library will be different from language to language. You know, what you choose and how things happens is completely different from one to other. Okay. Okay, so that's on the language. So now when we talk about developing a chain code, the things what we are going to use is we're going to use Fabric API. Just so we're going to use a Fabric API. So they have developed, or when I say they, is community has developed an API for every language. So you'll be using Java API to develop the particular chain code. And as we discussed, we'll be building the Gradle project. So since we're using Java, we'll be using Gradle project. Okay, and with respect to the packaging a chain code, so basically what we do, that particular when we package it, it'll create something like this. Okay, tar.gz. Okay, this is the packaging what we are doing. So once you package it, basically what things which we're going to mention here is, so you will have some metadata. So in that metadata, we will be mentioning is like, what language is this? Okay, this is a language is Java. Okay, and then we give something called as a label for our chain code. So now label will be, for example, the chain code, maybe let's say we're building something like a car showroom. Okay, so we'll just say car showroom _1 or something like that. Okay, now once you package it, and then we need to install it. Okay, so we need to install on all the organization, right? So for that, what we need to do, so once you package this, right? So every time when you package it, you get a package ID. Yeah, so package ID. So something like the above step car showroom _1 is the package which we created. And then it will have some transaction hash, a unique hash will be created. So this is the package ID you will be using to deploy it onto every organization. And once you actually kind of install in all the organization, you kind of get a response telling that whether the installation is successful or not, and you get a particular what do you say transaction hash as well when you do that. And otherwise, and after this, so you will have to do your approval, right? So that's your next step. See, when we go to the approval, the things what we pass here is we pass the chain code name, we pass the package version. See, now package version means very first time when you're writing your chain code, let's say your version will be car showroom _1. Okay. But after a few days, you made some changes to your chain code. When you want to deploy your new chain code, then you will have to pass the new version of the chain code. Yeah. So that's a version, and sequence will be on which order it is going. That also you need to mention it. And then one more thing, what we also mention here is the endorsement policy. Okay, I hope you guys remember what is endorsement policy, right? Who can approve, who must approve, right? These details. And also obviously your package detail, above package, whatever we created here. All right, okay, so that's the step. And final step is committing. So now what we do here is we need to commit the chain code in channel. So between or among organizations, there are channels, right? In the channel, we'll be committing this particular chain code. So that means this chain code will be running in both the peer. Okay, keep that in mind. Now, for example, now if we install this chain code on this channel, so that means the chain code will be committed to organization 1 and also to organization 2. It has to be running in both the organization. Okay, that's your committing process. All right, okay. Now, what we are going to do here is we will develop one chain code to solve some real life problem. Okay, a kind of an example problem we'll be going to solve it. Otherwise, I'll also show you some more examples as well. For that development, we'll be choosing Java, and then we'll be using Gradle as a development. Is all of you familiar with Gradle? Okay, let me explain this. See, when we talk about Java project, and then Gradle, I'll explain you this. See, the things, you take any project. What we do is you write a program. Forget about blockchain or anything. Okay, you just let's say you're building a project, Java project. When you build a Java project, it can be microservices, or it can be distributed application, or it can be anything. Now, whenever you build a project, there are some things which you do it regularly. Okay, so I would call it as the day-to-day activity. Okay, so day-to-day activity in that particular project will be, so you need to compile that project. Yeah, you need to build that particular project. Okay, you need to run the all the unit tests or anything. Okay, and then you need to package it. Package it means not the chain code package, right? Basically creating your jar files for this product. Now, whether it's a blockchain project or non-blockchain project, okay. Then after that, you need to release this particular code into your test environment, production environment, or anything like this. Now, when you are doing these kind of activities, what you will do is you will be doing the same steps again and again and again and again, right? So now, what one of the biggest principle what we say here is, uh, this is being mentioned by Martin Flower. What it says is, human beings are here to solve the problem. Machine does the repetitive task. Okay. So now, what does it mean is, whenever you're doing something repetitively, just automate it. So basically, what we're telling here is automation. So you would have heard something like a DevOps, right? Which a part of that, but DevOps is a really big one. So in the automation, what we are telling here is all these steps we need to automate it. We don't need to manually do this and waste the time. Okay. So for this reason, we will be using a Gradle. So what your Gradle helps? Gradle helps you to compile your project, build the project, run the test, and then package the project and release the project as well. And once you write all these steps, you can even put this in your Jenkins pipeline or Azure DevOps pipeline or anywhere, and you can automate it. We're not going there. But then now what we're going to do here is we will be using Gradle project so that your build process, everything becomes much easier. And similar to Gradle, there are other things as well. You would have heard like Ant, Maven, Gradle, and a Gulp. These are the things. Ant is the one which was launched very long back, like in 2000 something year. That time is when Ant was launched. And after that, in 2004, Maven was launched. Maven is being used heavily. Okay, and if you see any Java project, you will see that Maven is being used. But after Maven only, we started to see Gradle. Gradle has become more powerful than uh, Maven. Okay, Gradle. That is because uh, Maven is more like Java project or more configuration you'll have to provide. But whereas Gradle, you can use this Gradle for a multi-language. Okay, whether it's a C++ or it supports multiple languages. It helps compiling, building, and deploying and everything. And then it is scalable, and it is the performance is much better than Maven. It's the simplest to maintain, and there are a lot of support it provides for us. Okay, so let's quickly take a look at that in the so accelerate developer productivity. 1 second. Okay, see, from mobile apps to microservices, from small startups to big enterprises, Gradle helps to build, automate, deliver projects better and faster. Okay, so build anything. It's written in Java. Sorry, write in Java, C++, Python, or your language of choice. Package the deployment to any platform, and you can deploy it. Okay, so that's the power of Gradle and why we use Gradle. Use Gradle's rich API, mature ecosystem, okay, and deliver faster because you're able to automate things, right? You'll be able to deliver faster. and it's being used by many organizations. You can see all the big organizations. Okay, cool. All right. So now I'll just show one sample here. Okay. See now, take a look at this, and this is a chain code for a fab car. Okay, I'll explain you all that. Now, when you create a new Java you'll be using Eclipse. Okay, in my system, I'm showing it in VS Code, but when you do the hands-on, we'll do it in Eclipse. So you'll be creating a Java project. It'll look like something Gradle project. It'll look like something like this. And the one important file in this Java project is build.gradle file. So build.gradle file is the main file where we mention all the details. Like there are mainly few things which we mention. One is called as a plugin. The plugin, what it tells us, for my project, this project, what are the plugins I needed? Okay, so now I need a application plugin, Checkster style, Jacoco is your code coverage tool, something like that. Okay, so whichever plugins you'll be using, you'll be mentioning that under plugins section. You can think like it is your configuration file for your Java project. This is same as a pom.xml when you're using Maven project. And after that, you're just giving a name for your project. Okay, that's a group I've given, and the version of that particular project, 1.0 snapshot, something like that. And another important thing is a dependency. See, the way Java, Python, and all these big languages works here is you don't need to reinvent the wheel, right? You already know that. For example, if you want to do some mathematics, right, you don't need to write a program. What happens when I do tan theta plus cot theta, right? So instead, what you will do, you will be using some of the packages written by the public or written by the community, right? So in that way, you can do much faster. So that way, whatever libraries you will be using it in your program written by someone else or a package as you call it as, those things need to be mentioned under the dependencies. So what we do under dependencies here, we mention, let me just move this here. Here we mention it telling, okay, I'm writing a chain code. For that, I need this particular library. Which one? org.hyperledger fabric chain code Java. And the version is fabric chain code shim, that 2.0 version. And then I'm using some other packages like Jensen. This is to convert into JSON. And otherwise, I need Fabric shim another version and JUnit to run your unit test, and then Mockito for your unit test mocking, something like that. Whichever libraries packages you'll be using, you will mention it on the dependencies. Now, when you build your code or when you compile your code, what actually should happen is whatever dependencies you have mentioned here, these dependencies needs to be pulled from somewhere, right? So that is called as a repositories. So we mentioned that, above dependencies, whatever we have, go pull it from a particular repository. It will be there, just download it from there. That is what we're calling it as a Maven here. So now what we are telling is that these repositories are available in the hyperledger.jfrog.io this location, and then go pull it from there. So when you compile it, it will pull everything. Similarly, so we have some more things, right? We have a JUnit and we have some more Jensen and other things. Those things will be pulled from the Maven repository and then the JCenter repository. So you can mention, if you're using your own repository, you'll be able to mention that here. Okay, so far what we have done here, so we mentioned what plugins we need. We mentioned what are the dependency for our program. And then we've also mentioned, from where it needs to pull. And otherwise, whatever the plugins you have mentioned here, you're just putting some more configuration for that application and what I'm using, how the check style, what I'm using it, and other things. This is some additional steps you can do. All right. Okay. So now that we've understood about Gradle project. Okay. The next thing what we want to talk about is Fabric API. Fabric API. Write your chain code. Okay, so let me go to Chaincode here. Yeah, okay. So what they have support for Go language, Node.js, and then the Java. Okay, so let's talk about Java here. So Hyperledger Fabric Smart Contract Chaincode API, Java Contract API. Okay, so this is what we're going to use now. So Hyperledger Fabric offers a number of SDKs to support developing smart contracts with this chain code, the various languages. There are two other smart contracts that go on Node.js is available. Okay, so this section is available. Hyperledger Fabric adjustments here, and the dependencies as we mentioned here. So in your Gradle project, so you'll be mentioning like this: org.hyperledger fabric -chaincode Java, and then the shim and the particular version. And if you're using a Maven, and you will have to mention this under this particular group ID. Okay, under this dependency, this is what we're mentioning. So we're telling we will be using this package. All right. Okay. So we have this code. We'll take a look at that. They have two versions here. Okay. So let me pick one version and explain you that. See, in this particular Fabric chain code shim, there are some packages are available which will be using it. We have this org.hyperledger.fabric. So we'll be using this to logging classes. Okay. Hyperledger.fabric.contract. This is mainly used, provides interface and classes to support contract programming language. So when you're writing your smart contract or chain code, you'll be using this particular package. And we also have something called as a fabric.contract.annotation. So annotation means it's basically a decoration of your smart contract. A decoration in the sense you might have written two functions, but among that there's only one function which is actually a smart contract function. Otherwise, other function is a regular function. But how do you tell that, okay, this is a smart contract function, right? So you'll be using annotation. So like that, there's a lot of things you'll use annotation for. Also have a fabric.metrics, provides an interface to classes to support collection of metrics. And we have a shim, provides an interface and classes required for chain code development and a state variable access. This is very important. Now, when you want to insert data to your ledger, or when you want to read data from a ledger, you'll be using this shim heavily. Okay, otherwise you have some more things. So let's take a look at important things. The fabric contract. So the fabric.contract, we have contract interface and the contract identity context class. Okay, contract interface. So when you use a contract interface, there are some things like it supports create a context before transaction, after transaction, things like that. Okay, let me explain this 1 second.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Take a look at this. Let me read this. All contracts should implement this interface, okay, in addition to contract annotation, which will be adding it. All the method on this interface have a default implementation. For many contracts, it may not need it. Each method on the contract that is marked with the transaction annotation, okay, is considered as a transaction function. That when you put the transaction annotation, then it will be treated as it's a smart contract function. This is eligible for calling. Each transaction function is supplied with the first parameter called as a context. So whenever you call any of this transaction here, you'll be calling this context. Okay, so let's take a look at what is context here. When you see the code, you'll better understand. Okay, so the context is, see this, what we are doing. The context is available to all transaction functions and provides a transaction context. It also provides access to the APIs of the world state using get state. Okay, so basically context means it's a current context for which chain code are you referring to, or for which network you are referring to. So once you know that for which network you are referring to, then you'll be able to access the ledger inside this chain code. Okay, now these are the four methods what you can use: after transaction, before transaction, and create context, and the unknown transaction. If I go one step back, let's take a look at the classes available here. Classes identity. Okay, so that's on your contract, and then we have this annotation. Yeah, so you see this lot of annotations are available. One is contract. The way you use it, let me see some examples here. At Hyperledger Fabric contract annotation.info. I don't see any examples here. Okay, I'll show it an example later. Okay, it'll be something like this. At interface is what we're using. So our data type default info license on the property field. So we mentioned something like this. Okay, we say at property. At property means whatever the variable we are creating it here, and we are telling that that is part of your smart contract. Okay, that's where we use something like this. Similarly, when you're creating a transaction, you just mention that at transaction. So let's go to our transactions here. Method level annotation indicating the method can be callable transaction function. All right. Similarly, what we have license is fine default. Mainly, what you use, you will be using at contract, at the property, at the data type, and then the transactions. Just an annotation with decoration. Okay, so now I'll go to another important one is this your shim. Okay, the shim is important. Um, Provides an interface and classes required for Chaincode development and a state variable access. State variable means the data which is stored on the ledger. Okay, so here we have Chaincode stub, enums and exceptions. So if I go to Chaincode, public interface Chaincode, yeah, okay. These are the two important methods what we use when using this Chaincode. One is something called as a init, and another one is called as a invoke. Um, so this init method, when you are executing it, basically whenever you are installing a chain code, and if you want to set some default values for your particular smart contract, you'll be using this init method. So init method is called during the instantiate transaction after the container has been established, allowing the chain code to initialize its internal data. Okay, whenever you want to do any default or any initialization you want to do, you'll be using this init method. And then we have invoke method. So in your chain code, you have written two functions. And when you want to invoke a particular function or execute any function, you'll be using this invoke method. You'll use this invoke method, and then you pass this stub. Stub is nothing but an intermediary between your chain code and then your context. And you'll be passing that particular stub information and the chain code name, sorry, chain code function name. That function will be executed here. Okay. Invoke called every transaction. I explained you this. What are the things you use? Chain code. What are the other interfaces we have here? Okay. Just go one step back. Shim. Okay. Okay, and the interfaces, chain code we have seen. Okay, so there's a chain code invoke. I'm just seeing, is there any important things which I need to show you guys? Okay, no problem. I'll explain it. I don't know where this particular link is here. See, this shim package has two more things. Okay, one is in the previous step, what I showed is um, you can write functions in your smart contract chain code, and then to mention that as a callable function, you will be using annotations, right? At transaction, at variable, you will mention it. And you will be passing the contacts, you'll be passing the stub I mentioned. And the next thing is you want to insert data into your ledger. Okay, for that, you will be using put state function. Okay, put state and then a key and a value pair. And the way we insert data into the ledger is key and a value pair. So you call this function put state and then pass the key and pass the value, which will insert data into your world state ledger, also to your transaction log. Similarly, they also have something called as a get state function. So using that get state, I'll show you with the code, you'll understand better. You'll also use a get state function. Get state will go to that particular ledger. When you're saying get state, you need to pass that particular key. So for example, see if you put something like this, okay, you called as put state, then you mentioned key is equal to value like this here if you have inserted, okay. Then when I'm saying get state, I'll say send me the details of key 1, then I'll get this answer Arjun, okay. So that's how your put state and the get state works. And then one more thing, we have invoke function is also there, so you can pass a particular transaction name. Okay, I think this should be enough. Otherwise, what else I have? Packages, metrics, shim. Okay, so let me just clone this repo and show you if everything is there. Okay, now I will show you how we use this particular libraries here. Okay, as I explained, so the steps what you're going to do here is you first need to create a Gradle project. Once you create a Gradle project, next step is you need to configure your build.gradle file to mention I'm going to use these dependencies. We'll be doing this hands-on, okay? And after that, the important part is I'll take one example here, how we write a chain code. Now I have this car.chain code. Okay, so now here I'm just defining one car here. Okay, so what I'm doing here, if you see, I'm importing org.hyperledger fabric contract annotation data type, and then the fabric contract annotation property. These are the things what I'm doing, importing it. And if you see here, I'm creating a basic Java class only. I hope you guys know all the programming, so I'm not going to go detail into this. So I'm creating a class called as a car, and for that I'm putting annotation here. You can see that the annotation is a data type we added. And then inside this car class, I have some variables I've created. For that, I use properties here. Whenever you have a variable, you'll be using this annotation. Okay. And after that, what? After that, this is regular. Okay. Now this is your main smart contract. Okay. So in this smart contract, I'm using Fabric contract context, contract interface, contract annotation .transaction, and then also Fabric shim chain code, Fabric shim ledger key value, and then other things as well, right? Okay. And whenever you're writing this particular program, the first thing what you need to do here is you need to use this at contract annotation to give detail about your smart contract what you're writing. Now the smart contract what I'm writing is called as a fab car, and some information I'm adding it. Okay, the info at I use at info, and the title is fab car smart contract, and description, this is Hyperledger car contract, and the version and the license, who needs to be contacted, email ID, address, and all that. Okay, just a like a metadata about your smart contract. So you'll be using this at info here, and everything comes under the at contract section here. Okay, and after that, what we are doing, we are creating a new smart contract called as a fab car, and which is inheriting or implementing the base contract, which is contract interface. All right, okay, and otherwise it's just a regular program. Okay, and now I'll just show you two things here. Okay, so now in this smart contract, I have a function called as a query car. Now this is a smart contract function. I'm going to call this as a at transaction. And to query a car means, but before I show query car, okay, let me explain you first this init ledger. In this particular smart contract, what we are doing here is, you will be able to insert car detail. I think like this is a smart contract for car showroom. So you have a car showroom. For that car showroom, you have so many cars, and all these cars you can treat it as an asset. and you want to insert that particular car into car detail onto your Hyperledger Fabric network. And when you sell this car to someone else, you need to change the owner of the car. Okay. So what we are trying to do in this smart contract is, very first time when I'm running my smart contract, when I'm initializing it, I want to insert some basic car details. Okay. So the make will be Toyota and the model and then the owner and the other detail. Okay. Then in that case, we'll be using init ledger. So the way it works is we have to give our transaction so that we know it's a smart contract thing. And the name itself, init ledger. This is the name of the function. And you pass the current context. Using the current context, we get the stub. Okay, this is a common in every program. So you pass the current context and using the CTX and we getting the stub. Once you get the stub, then you'll be able to insert in. And after that, what we do here is very simple. Stub dot put string state. You remember I talked about put state, get state, similar to that, put string state. That's because whatever car object we have in the Java type, we're just converting into a string JSON serialization we are doing here, and then we are inserting in the string format here. So use stub dot put string, and as I mentioned, you will pass a key and your actual value. This is how you insert data into your Hyperledger Fabric ledger. Okay, so the next thing is now we have written some more functions here. Like anyhow, I've showed you this. Okay, so one is a put string state. Another one is to query, right? To read the data. So I'm just writing a query car. This query car. What we do here is, if you see here, similar thing. So you pass the context. Using this context object, I'm creating a stub, and using just a stub dot get string state and a key. So I've inserted a car with ID 1. Now I pass this ID 1 and I get all the car detail. This is basically going to read value from your Hyperledger Fabric ledger. All right. Okay. So we talked a lot about this. Don't get confused, but at least you have some high level idea on, what is this API and what's this Gradle project and what are the packages are available. We have seen how do we use it as well. Okay. What we're going to do now is we will be creating a chain code. So before to that, let me just refresh what we have learned. Okay. So the things what we have learned is, when we talk about chain code development, the life cycle is, first you develop the chain code, then you package the chain code, then you install the chain code on all the organization with the package ID. All the organization, they must approve. They look at the chain code, they approve it. Once approval is done, then you commit the chain code onto the channel. Once it is committed, you'll be able to access that particular chain code. Now, to write a chain code, you can use any of this language. We're going to choose Java. And then to build that particular project, we'll be using a Gradle, which will help us to automate all the manual things like compiling, building, running a test, packaging your Java project, and releasing the Java project. And then we'll be using this Fabric API to write your chain code, right? Majorly, there are put string state, get string state, and then the context object and the stub object, and those things will be using it. Okay, so now what you need to do is, let me just give me a second. Okay, so now can you open this in the Explorer, Windows Explorer, folder Explorer? This VS Code maybe. Close this VS Code. Okay, yeah. So now open your folder. Fabric sample. Can you cut this entire folder? Right click and cut. Yeah, cut that folder. Now open your Eclipse underscore. No, stay there. Eclipse -workspace folder. Paste this here. So this is for all of you. Please do this. So move your fabric.sample folder under Eclipse workspace, because Eclipse workspace is the folder used by Java project. Others, please confirm me if this step is done so that we can move on together. Okay, great. Okay, now you can close this folder. Okay, close the entire folder. Yeah, okay. Now open your Eclipse. So we're going to do everything from scratch. Okay, we're going to build one chain code. Okay, so you opened it. Now we'll create a new Gradle project. On the Eclipse, click on File, New Project. Okay, so File, New Project. Yep, select that project. Select Gradle project. Okay, now stay there. One sec. Click on Next. Okay, click on Next. Now here, one second, give a project name as a car showroom. C, capital C, everything is lowercase. Now what we are doing here is we are building a smart contract to Chaincode for a car showroom, like I explained before. So where using this Chaincode, you'll be able to manage the entire cars. It can be BMW or anyone in that matter. So where we are writing a Chaincode, from that you'll be able to insert any new car detail, and then you can query any car with the car ID. And also, if anyone buys that particular car, the car ownership will change. So that ownership detail will be captured in our Hyperledger Fabric. So that if after 10 year, if you want to know who owned this car 10 year back, you can just come back to Hyperledger Fabric and you know the complete history. All right. Okay. So in the second option, project location, uncheck that. Yeah. Okay. And browse, select Eclipse Workspace, Fabric Samples, and Chaincode. Okay. The screen is big. That's why you're unable to see. Maybe make it smaller. Okay. Yeah. Open. I'll just wait others to confirm me. So one request is, let's all do it together. If anyone is behind, please ask us to stop, and then we can, so that we don't need to repeat things. Okay, now click on finish. At the bottom right, you have finish option. Okay, I can see that the project has been created. Just wait others to confirm me. So we have created the project. The next step is, now here you see a car showroom project. Now this is your Java project, yeah. Okay, so now it's running on Java 1.8. We can see that you have a Gradle folder. So for some people, it might look different. Okay, so you will have two folders. One is like a car showroom, another one's a lib folder, or you will have everything inside. So no difference. Okay, both are same. Okay, so should be okay. So let's go with the Java 11 version. Let's see if we have any issues, then we can fix that. That's fine. Let's continue. Okay, that's fine. Let's continue then. Okay. So what have you done now? All right. Okay. Okay. Let's continue here. So let me quickly explain this project now. So you have created a project called as a car showroom, which is a Gradle project. Okay. Now, if you scroll down, you see that build.gradle file. Yeah. Okay. Open that. Double click. Yeah. So as we discussed, this is where we're going to mention all the dependencies. Okay. So let's do that first step here. So now under your plugins, I'm going to use the same code share link, okay, so that you can copy from there. So I'll put here Chaincode step 1. What you did, create a new project. Just put it here what you did. So when you come back tomorrow, you can see you create a new Gradle project in Eclipse. Okay. So the step 2 will be modify build.gradle file. Okay, that's what you're going to do now. So now under this plugin section, add this one. Make sure you don't miss anything while copying. So we're just saying that we need this style check style plugin and then Java library distribution plugin. Okay. And let's give a name. So add this under that group as a car showroom, and then the version is 1.0.0. Yeah, take this entire two line and put it under repository. No, do one thing. Remove whatever was there. Replace the entire plugin section. Yeah, copy like that. Yeah. No, maybe quit and open again. If there's something wrong. Okay. Now, after the plugin, no, that should not come under. No. Wait a second. I'll do one thing. Wait. I'll put the entire file content and just copy paste this content. Okay. Do one thing. Can you do select all and delete from that file? Okay. So now I'll put the complete file so that you don't miss anything. Yeah. Take this full code. Make sure you copy everything. Okay. Now you can see that. So we're using a plugin check style Java library distribution. And we're given a name as a car showroom and the version is 1.0. And the repositories we are telling, so go pull all the libraries and the packages from Hyperledger Fabric, jfrog.io, Fabric Maven, and other things it will pull from the Maven and the JCenter. Now scroll down on the third important step. For this project, we have a dependency with these packages. The first one is org.hyperledger fabric chaincode and chaincode shim. And then, yeah, that's a main thing we're going to use. And then the Jensen is just to convert your object to JSON and some mathematics, some other things, okay? All Java related libraries. All right, okay, so just to control S. Okay, so now right click. Okay, I'll just wait others to confirm me if others have done the same thing. Is everyone done till so far? Okay, great, yeah. Now right click on the car showroom project. Now what we are going to do here is, whatever the dependencies we have mentioned, let's pull all the dependencies. Okay, yeah, right click on the car showroom. No, here in the Eclipse, yeah. Now here, scroll down, you select that Gradle, you get an option there, Gradle. No, come down. No, you see Gradle little up, yeah. Click on refresh Gradle project, yes. So it's going to pull all the packages. It's done for you. Because you could minimize that thing, right? That's why it did not show the progress bar. You can see that. You see that project and external dependencies folder. Yeah, everything it pulled. See this Goa, Fabric, and whatever is required, right? Everything is pulled here. Okay, great. It's the same with others as well. Did you please make sure you refresh this? If you don't refresh, you'll not be able to access this when you're writing a program. All right, okay, cool. Now you can, now what we are going to do here is, we will be adding two classes, okay, in our chain code. One chain code will define the car object, and the second chain code, so second class, Java class, is where the actual implementation will be writing. Okay, so now right click on the car showroom project. All of you, please follow along. Select new class, select class. You're creating a new class. Yeah, there you go. Yep, select that. Okay, I'll put that step in the document. So step 2, create a new class. Okay, now call it as a car.java. Okay, the name is capital C, yeah, car.java. Just stay there, don't click anything here. Now, one thing is, just, that's okay, that's naming convention is fine. See, one thing, make sure like you see the similar view, like, okay, so the source folder is car showroom src main.java, and the package what it's going to use is a car showroom. That has to be selected. So right click on the car showroom, new, and class, and then the name is car.java. Okay, so now you can click on finish. Okay, all right, so now we can see that our car.java, we have actually created it. Okay, so okay, now the first thing what we are going to do here is we're going to import all the statements. So import all the packages. So let me put this content here from the file, but don't just copy paste it. That's the kind of, try to write by yourself very first time when you're writing it so that you know what you're doing. Okay, I hope you already written that. If not, you typing it, but otherwise later you can even copy from there. Okay, just to make sure that you've not missed anything. All right. Okay, so now we have imported all the required libraries. Okay, so then now let's use some annotations there. Okay, under your data type, okay, let me give this thing once again. So what we are going to do, we're going to create a new car class. Under this car class, okay, can you show that one second? Okay, inside this car class, let me just give you guys 1 second. Because our car needs to have the car name, car ID and everything, right? So just type this. Okay, all these properties will come under car class. Okay, just type this properties. Okay, all right, so you've added this property here. Now we have put the annotation for also for the class car also you put the annotation. Okay, so what you're going to do here is before your import statement, just add this line. So line number 147. Yeah, that's another annotation which we are adding it. Okay, so now what we have done so far, we've imported all the libraries, and then we have created the class, and we have put that annotation as data type. Okay, and then we know that to store a car information, we need to store car ID, car model, car owner, car value, basically what is the price of it. In a real life, you can create more variables as well. Okay, don't worry about that. When we see a build, we get that error. Okay, and then we've written some getter and setter methods. That is because you have created all the variables as a private. You see that the line number 11 created private final string ID. Yeah, that means if anyone want to access that ID, they'll not be able to because that's a private item. If somebody need to access this, then they'll call this get ID function. Get ID, get model, get owner, like you're showing. Okay, next we will create one constructor. So this constructor will initiate a car. Can you see that code share and then write that content? So for some time, I suggest you guys to write the program, because if you just copy paste it, you may not know, you may not find it to debug, becomes difficult. My suggestion is just to type in these things.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Along with your Eclipse. Okay, now I'm going to put the complete code there. Okay, so what I want to do here is, okay, I put the complete code there. I want you guys to type most of the things. You need not type everything, but at least try to type some of the things and try to copy paste some of the things. So I put completely. Okay, so what we want you to do now is take some 10 minutes of a time to finish this. All right, okay, so shall we continue? Okay, all right. So now what we have done here is we have created our first class, car.java class, and where we have defined all the variables for our car class, and we have written all the getter and setter methods. And we have also written the constructor at the bottom, what you see, the car. So basically the constructor is whenever you're creating for the first time, and it will initiate all these values. You're seeing a lot of reds there. We will fix that. Maybe some your Java issue or something like that. But let's continue here. Okay. Now save this file. Now scroll down, please. You see some of the methods what we have written here is you would have heard a term called as a override in object-oriented programming language. Override means you have a function which does some behavior. Now, when you want to modify that behavior, we use that override. If you see that line 46, yeah, so we use that override keyword. And whenever we call equals, instead of doing the standard way, do it in this way. Okay, so that's what we are doing it here. Whenever we say equals, it will check whether the car object is equal. That's what it does. Similarly, we have written for hash code that will generate your SHA-256 hash code. And then toString conversion, we are doing it at the last. Okay, now we will write our smart contract, the next thing. So now can you do the same thing now? Can you right click on the car showroom project? Click create a new class. So I'll put it in the document. Step 3, create a new class. Car transfer.java. Copy that from there. The code share. Okay, make sure that's under the car showroom package. Okay, all good. Yeah. Now click on finish. Yeah, that's fine. Yeah, final is fine. Yeah. Okay, now this time you're going to import a lot more other packages. Okay, so import these packages now. You see here, what are we importing? Hyperledger Fabric contract context, Hyperledger Fabric contract interface, annotation, annotation default, info, annotation transaction, and Chaincode exception. Whenever any exception comes, how are we going to handle that? And then finally the Chaincode stub. These all respect to your Hyperledger Fabric API. Okay. Now let's continue here. Now just below your import statement, just add this one. So now we're going to use a at contract annotation. If possible, try to write it. Few lines you write it, then few lines you copy. Just write few lines at least, so that you know what you're doing. But, see, I'll give you one tips here. Whenever you learn anything new, try to type by yourself so that you learn that. But later, anyhow, you can do a copy paste. Okay, all right. Now you have written that. Now for our car transfer, let's do some more decorations there. Let me put that. So let's do at default for our car transfer. And then just modify that because we need to implement the car transfer. Okay, all right. So now that you added that, now what we are going to do, let's just create some two variables here. So under this class, we are creating just one Jensen variable that is just to convert our class. All right, so just put the two variables there. Copy from the code share. Okay, don't worry about it for now. Finally, before we compile, I'll give you a full code so that you can copy paste that. Okay, so now this is important. Now what we are going to do, now create a new function which is init ledger. Now this one I want you guys to type it. Okay, so please don't copy paste. This is an important method. Here you'll be writing everything is a chain code. So write all these lines of code, very few lines of code, but write this by yourself. So what this is going to do, we are using a at transaction annotation to mention that this is a chain code function. And the next thing what we are doing here is we're calling the function called as a init ledger. So very first time when you're initializing your ledger, that's going to initialize ledger with the default values. And to initialize a ledger, we need to pass the context variable. Once you pass the, can you please go back to that screen? Share. Yeah, one second, let me explain this. Okay, so to initialize a ledger, you need to pass the context variable. On the line 246, you see that CTX we are passing. Okay, and the line 248, what we are telling, using the CTX object, we are getting the get stub. Once you get the get stub, and after that you can call any function. So now here, in the previous step, you created a car class. Yeah, you remember? So that's a 250 line. We are creating a new object of type car. Car is equal to new car. That's a regular standard way. So we are creating a new car with the car ID is 1, car name is Maruti, model owner is Mark, and then the price of the car. And after that, we're using this Jensen to convert object into string. Okay, that's a serialization. We are doing it regular Java. And finally, you see the last line, stub dot put string state. This is where it will insert this value into your Hyperledger, Hyperledger Fabric ledger. Step dot put string set key and a value. Your key is 1, that's your car ID, and the value is the complete string, car state string, you're inserting it. Okay, so now that you understood, so please type all of this. So I encourage, don't copy paste, so please type it. No, don't copy paste, don't copy paste. Oh, you're going to watch there and do it. Okay, no problem. Yeah. All right, okay, so now you have written your first method. Okay, so next transaction method, what are you going to do? Once you have initialized it, we want to write a method for the add new car. Okay, so now let's add another method for add new car. So this is your smart contracts next function. So like we did, please write by yourself. Okay, awesome. I see that you guys have writing it and you have written it. Yeah. Okay, so the next step, what we are going to do here is we will write the remaining functions now. So now that we have added a add new car, the remaining functions would look similar. Okay. So the next function, what we're going to write here is query car by ID. Once we added a car, we should be able to query that particular car. Yeah. So let's do that. So now add this next one. Looks very similar one based on what you have done before. So very simple. So we just use our transaction and then we are creating a context object and we need to pass the car ID, right? On the line 66, see that we are passing the string ID. And after that, get stub and then stub dot get string state. That's going to return the car details. And then you're just checking whether if the car is empty. That means the car ID which you're trying to search for, it doesn't exist. So we just need to print telling that the car doesn't exist. But if the car is exist and you get the return, you get the value, then just return this car object, right? So that's what we are doing now. So now let's write the last very important function is once the car has been bought by someone, that needs to be sold to someone, right? So that one we are writing it as a change car ownership. The last function starts from 298 line. So we're saying change the car ownership. We are doing the same thing like create a car owner, but in this case, only thing what we are creating here is we are updating our record with the new owner. What will happen here is, so you have a car ID, a 1, which is owned by Mark. Now the new owner will be Arjun, right? So we're going to update that with the new car ID. All right. Okay. So now what I'm going to do here, I'll put the complete code in the document. I'll delete whatever I've written there. I'll put everything with the commands and everything. So you can just copy paste that full code and write it there. Okay. So that you don't make any mistakes there. So I'm going to delete whatever I've written from 217 line till bottom. You can copy this entire code. Just wait a second. So I'm going to delete this. So I'm going to put this line. Right. So now copy from 217 line till bottom and replace everything in your card transfer.java file. This is the working code. Select all, delete and paste again. Okay, do Control S. All right. Similarly, I'll change that the first file what you created, right? car.java as well, just to make sure you're not made any typos there. So let me just replace that. Just wait a second. I'm just making some modifications here. All right, good. So from line 140, copy till 212. The car.java. Yeah, that's right. Okay, I don't know why you're getting error. You should not be getting error for do Control S. Okay, now one sec. So let me change. You modified your the gradle.build file as well, right? Just verify that. Or you copied whatever I've given, right? Okay. I don't know why you're getting red there. Okay, right click on that car showroom and then can you go Gradle and refresh? Do that refresh. There's something it's getting downloaded. You see 131 MB of 1347 MB. Wait a second. Wait. I'll just something here. Maybe. Why is that string is showing this one? Can you mouse over on that? How can string will be? Okay, so I want you guys to fix that later, okay? But I'll tell you how you will be doing this one, okay? Just give me a second. Now, can you open your terminal? The terminal, go to this folder, cd into that Chaincode car showroom folder. Till that you go. I'll put a comment in the next step. Okay, cd into that folder, and then execute this Gradle wrapper. Yep. Okay, you're in that. Okay, now execute that command. Line 363. Oh, lovely. Okay, great. So you should get something like this. Okay, your build should be successful. So Gradle able to build it. It's showing error somewhere. Eclipse leave that, but then it is successful. I just wait others to confirm me if this is same. Okay, others, please confirm me if all of you got this build succeeded. Is everyone got it like this? Build successful? Okay, great. Okay, now watch this steps carefully. Don't miss. Okay, now do one thing. Open your folders. Okay, so all of you please follow this step. This is a little confusing step. Okay, now what you need to do, go from beginning, go to Fabric samples folder. All of you please be in the same step. Eclipse workspace, Fabric samples is in Chaincode folder. All of you do along with me. Chaincode folder, car showroom, bin folder. Sorry, one sec. No, lib folder. Go back. Sorry. One sec. Sorry. So you are at Fabric samples, Chaincode, car showroom folder. Yeah, that's right. Okay. After you develop car showroom, where's the lib folder here? You're inside the lib folder, is it? Okay. Yeah, lib. Open the lib folder. Can you tell me on which folder you're in? Can you minimize that folder? The top view, it's blocking me. That's why. Yeah. So drag it down. Yeah. Thank you. Yeah. Can you make it little like extend this to the right side so that I can see the path? Yeah. Thank you. Nice. Okay. So now why is it creating a libs? So go one step back to car showroom folder. Go to car showroom folder. Okay. So no, wait. Don't click anything there. Car showroom. Do you see lib folder here? Okay. Now close this. 1 second. No, 1 second. Stay here. Show me that view here. I see bin is here, build is here, Gradle is here, bin src is also here, build.gradle is also here. Okay, maybe the new version which is doing it for us automatically. Okay, let's see that. Okay, fine. Let's try the step. Under car showroom folder, open that build folder. Others, please be on the same line. Car showroom build folder. Okay, now open this install folder. Close this. You're good. I'm seeing. No problem. You don't need to type. Yeah. Okay. You're right. You're at the right place. Don't worry, Anthony. So you're at the car showroom and the build folder. Open install folder. So others, car showroom build and install. Okay. Now we can see that the car showroom folder is created. Okay. Open that folder. Okay, very good. Okay, this is amazing. Yeah, the new version does everything for us. Whatever we are supposed to do, it has done for us. Very nice. To check that which version you're using. Car showroom -1.jar. Okay, lovely. So you see that the jar file. Okay. So now this completes our writing a chain code. So what we have done here is we have written the chain code and then we have compiled and we have built it successfully. So now the first part of your chain code development is developing a chain code is completely done. Okay, the error is no fine, not a problem. That's just your Eclipse error. If your build was unsuccessful, then we need to fix that issue error. Otherwise, no problem. Okay, all right, cool. Okay, I think so far we have done a lot of things. So now we know how Hyperledger Fabric works and where do we use and when do we use. And then we also learned about the architecture diagram. If we were to develop application for Hyperledger Fabric and what would be the architecture diagram. Okay, we learned about bringing up the network and we learned about writing a smart contract. So the next step we'll be talking about, we have also seen that after you write your smart contract, You need to package that, you need to install, you need to approve, then you need to commit this particular chain code. Okay, and we've learned about that writing a chain code can be written in many ways. One of the option what we have chosen was Java Gradle application. So we built a Java Gradle application where we used Fabric API to for our car dealership, right? Where you can insert a new car and then get a new car by ID, and then we have also written car transfer function. All right, okay. So now let's continue from where we are left. Okay. Okay, so the build process is done, yeah? Okay, so the next step will be, yeah, so open your project. Okay, great. So now, open your terminal. Okay, CD into Eclipse workspace / fabric samples / test network. No, just no. Wait. Go backspace. Hit tab button. Fabric samples. Hit tab button again. It'll autofill. Yeah. Test-network. Okay. CD into this folder. That is the file which is going to bring the network up and down and everything. Yeah. Okay. So I'm going to share all the commands one by one and execute this. So what we are going to do as a first step is we will bring up our network first. Okay. So once our network is up, then we will install Chaincode, package Chaincode install. Yeah. No, just put a sudo there. So you might need a permission. Yeah, execute that command. So what this command does for us is, if you have created the network before, and that's going to remove all the old containers. Okay. Execute the next command. This will just remove all unused containers. Now let's bring up the network. So we are calling it as a network.sh up command, we are calling it. And then we are also telling use a certificate authority and use the database as a CouchDB. That means your state database, your ledger will be Couch database. So if you have set up everything rightly, then this command should work fine. Let me know once this command is completed. You can see that here we have Hyperledger Fabric tools, Hyperledger Fabric peer is there. And can you just make it a bigger screen? I mean, just expand this. Okay. So now at the bottom, you can see that here, there are so many containers it's showing, right? All the containers it's showing. So if you see from the top, Hyperledger Fabric -tools.latest. Okay, that's the one container, Fabric tools container. And then what we have, Fabric -peer. Okay, that's the peer container. To start that, we use a peer node start command, and that is running on 9051. 9051 is your org2 peer 2. No, scroll down. I'll tell you where is that. Yeah, you see that under done, after done, you see below are the Docker containers. I'm talking about the second one, Fabric -peer. Yeah, you see that 9051. Yep, the below one. So keep highlighting that. You see that on the second line, we can see 9051. Yeah. And it says peer0 org2.example.com. Can you highlight that? Yeah, okay. So now, as we discussed, we are building a network with the two organizations, and each organization has one peer. Now, the first peer is peer0.org2.example. That means this is a peer running on org. Similarly, we can see the next one, next container. So just a below line, that is again Fabric peer image is running. And if you notice that, can you highlight the next line? Yeah, so you see that peer 0 org1 from the org1 peer 0, which is running on 7051, just in the above line you see. It's actually a one full line. It is divided into two lines actually. Yeah. Wherever you see 7051 port number where we are giving, 7051 is actually your container port of peer 0 org1. Wherever you see 9051, it is peer 0 organization 2. Okay. Yeah, that's important. And otherwise, the next container, we have a couch database. So that's your, as we discussed, that's your ledger. That's your state database. Yeah. And yeah, that's a couch DB. And then we have fabric-ca. That is your certificate authority. And the certificate authority is runs on 7054. You can see the port number. Okay. All right. So otherwise, yeah. Otherwise, this much is enough. So no, scroll down. Where is the orderer? Order is there, right? Already. No. Order is there, yeah. After peer. Yep, that's right. Yeah. Order runs on 7050. So this is very important. 7050 orderer. 7051 is your peer 0 org1. 9051 is peer 0 org2. All right. Okay. So our network is ready. And next thing, what we're going to do in this network, let's create a channel. There are you can expect issues in Hyperledger Fabric. Okay, don't worry. So now execute the next command, which will create a sample channel. You can read through the output. You can read the complete log and see what command it's used. Spend some 4-5 minutes on all of this from the whatever output it has given from blue, white, whatever colors you see. Read from beginning so that you know. Okay, you can see that the sample channel has been created. Very good. Sample channel got created and both the org1 and org2 joined the sample channel. So from top to bottom, just spend some time to understand. I have already explained this last week. So just understand from top to bottom the output of the create channel command. Okay. So now our network is up and running. So now let's see all the channels list. So before that, we'll just give access to a Docker socket. So execute this command. Then execute the next command. It will show the channels which we have created now. Okay, very good. So we can see that the sample channel has been joined. Yeah. All right. So now let's do the next step. Now for us to what we do. Okay. So let me explain this. So what we have done so far is we have our network ready. Okay, network with the two organization, 2 peer each, and your orderer node is running. Your coach database is also running. Okay, and we've also written our chain code. And if you remember from the life cycle, develop a chain code and package a chain code. Okay, and then install the chain code, commit. Now we're going to package the chain code. For us to package the chain code, we need to set some global variables. So do one thing, create one new file. I would suggest do one thing, open your VS Code. It'll be easier to create. Otherwise, you can use a Vim, but open VS Code. In the VS Code, open Hyperledger Fabric project. Go to code share. Yeah, just copy that file name, lifecycle setup arg1 and .sh. No. Only one. No. Copy only the file name from lifecycle _ yeah. So create a new file under test network folder. Yeah, right click new file. Yes, there you go. Okay, I'll just wait others to confirm me if others have done so far. And in this particular thing, okay, let me give the content. Now add the below content. Add the below content and spend some few minutes to understand what are the variables we are creating and which are the paths. So basically what we are doing here is we're just creating some variables. These variables, the next set of code, whatever we'll be executing, will be using that. Okay. Export path means we're just creating a variable called as a path and then we are appending things there. So take a look at all of this and see what is what. So wherever you see that path, right, wherever it says $pw, that's your present working directory. Under that, you can see organization, peer organization, organization, peer organization. If you scroll to the right, just spend some time to see all the whatever variables we are passing it there. Yeah, go to that particular folder and see what we have there. Okay, great. See, one thing if you have noticed in this variable section, most of the configurations, what we have done is for the org1 settings. Right, you see the local MSP ID is org1 MSP, and then even the root certificate file also org1. And MSP configuration file is also org1.example.com, and everything is org1. Similar to this, we're going to create one more file for org2 as well in the later exercise. Okay, for now, the next step is source this file. So basically execute this file so that all the variable gets added to our environment. Then we can use this. Okay. Wherever if I put a hash, that means you don't need to execute it. That's just a text. Okay. Execute that source command. Okay, great. Okay, now the variables have been created. Now we are going to do our first exercise, that is packaging the chain code. Okay, before we do the packaging, let's give a permission. So I'll put a comment here, package. Okay, execute this command. So just giving a permission. Make sure to copy the dot as well. Just giving a full permission to that folder. Okay, cool. I can see that you executed this command. Okay, so now we're going to execute this peer lifecycle chain code package command. So there's an important command which you're going to execute now. Okay, so the command is peer lifecycle and a chain code. Whenever you want to interact with the chain code, you'll be using this command a lot. Peer lifecycle chain code, and the next command is package. Right? We need to first package our chain code. And what do we want to package it as? We want to package it as car showroom dot gz. Okay, that's the zipping format which we are using it. Now, what we also need to say, where is this actual code is available, right? And we have created, we have compiled our code and we have kept it. Yeah. So that path is what we are mentioning it here. So mentioning it here under the chain codes folder, car showroom build install and a car showroom folder. This is the project which you created last week, and then we're just pointing it to the chain code location. And then on which language we have written it. LLNG is a Java. If you've written in Go or any other, you'll have to mention the language name. And whenever you package it, you will have to give some name, or you will have to give some label for that, because we will be using this label, when you're installing the chain code. When it creates a chain code package, it will use that detail. Just give me a second. So the label is car showroom _1. Okay. Execute this. If all good, everything should work fine. Yeah. Go ahead, do that.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Okay, nice. Now, can you do LS here? Awesome. You see that? On the red one highlighted, car showroom.gz. Okay, awesome. So what you have done so far, you have successfully packaged your chain code. And the next step in our life cycle is we need to install this chain code. We need to approve this chain code. We need to commit this chain code. Okay, that's the next consecutive step which we are going to do. Now we are done with packaging our chain code. Okay, the next step is we need to install our chain code on both the organizations. See, the way it works is once you have packaged your chain code in your Hyperledger Fabric network, if you have 4 organizations, you must install all these chain codes in 4 organizations. And one more thing, keep in mind, when you say install, it doesn't mean that you can start executing these chain code functions, because as you know, chain code is nothing but a business logic, right? This business logic, we cannot blindly write anything. Somebody has to review and approve it, because this is going to change how the business actually works, right? For that reason, what we do here, first we install these chain codes on all the organization. Once that's being installed, each organization, they will go through that what the chain code has been written, what's the business logic, and then they will have to approve it. Once the approval is done, only then we'll be committing the chain code. So that's a step. Now what you're doing is just installing the chain code on org1 now. Okay, now whenever I say install chain code on org1, you need to execute that source command. Go back, yeah, the 399, line number 399, yeah. So that you will have to execute. Okay, so execute that command. No, there's no dot sh. It is someone removed. Can you type dot sh there at the last? Yeah. Okay, execute that line. Okay, that's done. So now let's install this chain code. So I'll put this command. What step now? We are at step 8. Okay. We are going to install the chain code. Now stay there. I'll just explain that command. So what we are doing, we're going to use the same command like we have done before, peer lifecycle chain code, right? So we have used peer lifecycle chain code package. Now we are going to use a peer lifecycle chain code install command. Now what do we want to install? We want to install this package carshowroom.tar.gz. On where we want to install? We want to install on the peer address localhost 7051. If you remember, 7051 is the peer 0 or 1. And then we are telling we are also passing the TLS root certificate. And if you see $core, whatever we are passing, that is a variable we have already set in the source file. Now with this information, it will install it. Can you please run this? Just put it in a chat if this command is successful for others. Okay, awesome. You can see that here. Now it is telling installed. Yeah, installed remotely. Response status is 200. Whenever you get a response 200, that means it is successful. Now, one thing if you noticed here, when it is done, it created a package, right? See that package name. Package, just above line. No, yeah, same, both are same. Yeah, both are same. So it says car showroom _1, and then you see that hash code. Okay, that is the unique hash code for this particular chain code, which is being installed on the org1. I'll just wait others to confirm me if this is being done. Okay, great, awesome, very good. Okay, so now next step, what we are going to do is we will create another file. When you copy some code from that code share, please don't cut it. I see that some of you cut, you have removed some content. So please don't do that. Only copy content from here. Otherwise, when you refer this back, you lose things. Okay, so the next step will be, so I'll put the hash here, create a new source file. Okay, wait a second, don't copy that. I'm just still editing that file. Okay, now create a new file under test network folder as arg2.sh. Okay. Okay, I hope you guys have created this. Now under this file, let's add the environment variables for arg2. You cannot source it. First, let's add this file here. Okay, so I'll just add below content. Now, one sec. You'll have to add this pin.sh as well because it's shell script. Let me put one more line there. Okay, now you copy. Copy from 4162 to 424. Okay, so like you did before, just go through each of the variable and see the folders and files and where we are referring to. Okay, now source this file. So execute the next command. The next thing is we'll be doing the installation step. Now here we're going to install on org2. Okay, execute this command. Now if you clearly notice, it's the same command, but the local host is 9051, which is org2. Okay, awesome. So you get status 200, right? Very good. So that means what happened now? The installation is successful. So what we have done so far, we have our network ready in that network, and we've also chain code is also ready. We have packaged our chain code and we have installed our chain code. Great. Okay. Now let's check whether the installation is successful or not. Okay. So for that we use the query installed. Wherever I say on org1, first what you need to do, you need to execute the source command for org1, then execute this command. Okay. So what you do, first you execute this command org1, then you execute this. Okay. So it's going to show query installed command. Okay. There you go. Awesome. So you see that your package ID is being generated. That means it has been successfully installed, and then we are able to see that. Try the same thing on org2 as well. Okay, great. Okay, so now what we are going to do here is chain code query installed. It's being done. Okay, get the package. Okay, so now whatever package we have created, let's download this package. Okay, so to download this package, so can you please source the file org1? Now here, in this command, one important thing you need to do. Okay, sure, I'll wait. Yeah. You don't execute this command directly, it will not work. I'll tell you something needs to be changed here. Okay. Here life cycle. Okay, see if you see here, see that your installation is telling that chain code is already installed, but you did not execute that only. Yeah. No, you already done it. So your installation is done. Execute the next command. That execute that line number 434. Okay. See, sometimes what happens here is if you miss any step or even Hyperledger Fabric itself like that. Okay. So this is how it's going to be. Now, what I want you to do is you'll have to repeat the steps from beginning. Now, go back to the document. I mean, code share. Okay, go to the top. I'll tell you from where you need to repeat steps. Go to the top. Yeah, go to the top. Yeah. You see that now. Stop. Okay, wait. Line number 371, 372, 73, 74, 75, 76. Okay. This line, all of this you need to execute one by one, and then I'll tell you. Wait. Scroll down. Okay, wait. Let me put it in a comment here so that you know. I'll put it in a big. If anything fails, redo below steps. Let me put it below steps so that it becomes easy for you. Otherwise, you'll have to scroll through everything. So, Hyperledger sorry, Ethereum is easier. Okay, the Fabric is like this. So, this guy, source this file. Okay. Don't execute that line number 437. Okay, download package because there's something needs to be modified. Otherwise, others please, because the whatever you under 437 line, there's the one field which you need to modify and then execute. So let's wait till. Can you verify your both the source files in your VS Code? Go to your VS Code and check verify both the source files. Yeah. Lifecycle setup _1 and that both the file. Just verify if everything is right. No. Scroll down. No, those two files you open. No, lifecycle _setup. Go to that one. First file. Oh, just verify if this you copied it everything rightly. No. That is for org2, right? Okay, you're doing it for org2 only. Okay. Yeah. Now one more command you can execute and try before you doing this. No, wait a second. It will not work. You'll have to repeat all the steps. That's a problem with Hyperledger Fabric. Go to code share, copy line number 61, full top. Yeah. No, don't execute here. CD. No. Control C, Control C. Okay, go back to Eclipse workspace folder. No, in terminal only. CD space dot. Go back to Fabric samples. Yeah. Enter. Do it again. Okay, now you execute that command. It will pull the latest libraries. Okay, now you repeat all the steps from line 441. Repeat all the steps. Yeah. Okay. No. Wait. Now, when you're doing this query installed on 7051, you first source this one. Let me put this command. Okay, source this one. Executed 453 command and then execute 454 because you're running this on one. But I don't think that's the issue because issue is something else it's telling. Okay, there you go. It's working, right? Perfect. Yeah, that's working. Yeah. No, you can't do that. If you want to do that for two, that's fine. If it is working for one, no problem. You don't need to do it for the second one. Okay, great. So now we will download this package. Now go to 432 line number. Don't copy that. I'll tell you. Wait. Okay. Now go back to your terminal. Copy that package ID car showroom _1 till comma. Copy that. The output screen in the below. Package ID car showroom _1:17. Yeah, copy that full. Till no. Till only B0. Yeah, copy only till there. Now go back to the code share. Okay, so in the 437, you see that after package ID, yeah, replace that value. Okay, now you execute this command. This is same with all of you. So please copy your respective package ID and replace that package ID here. And since you're running it on 7051, please first source. No. Wait. Please first source setup org1.sh and then do this. What happened? Did that command executed successfully? Okay, now to confirm that, do ls now. Yeah, you see that? Car showroom, yeah, that's got downloaded. Okay, just wait till others to complete. Let me know once this step is done with from all of you. Just confirm in the chat. Okay, so now that we have network running, we have our Chaincode packaged, and we have installed the Chaincode on both the organization, and we are able to download things as well. Okay, so now the next step will be we will approve this Chaincode from organization 1. Okay, so let me put that to approve Chaincode. First, we'll source the file org1 file. Okay, then we execute approve command. Okay, I'll share that command. Execute this command. Command is doing, let me explain this. Peer lifecycle Chaincode. Now you see this approve from organization. Which organization we are approving? -o localhost 7050, that is the orderer node. Okay, that's a 750 is a orderer node. And after that, we're just passing which is the order certificate authority and which is a channel we are doing. -c is a channel. Okay, so we created a sample channel. And then - name is the car showroom. That is your Chaincode name. And which version of Chaincode? 1.0 version Chaincode. And we are also mentioning init required. That means whenever we're going to commit it, we're going to execute a initialization. Okay, this is good. Now let's what we are going to do. Now let's execute the same command on org2. Okay, so for that, let's first source the file org2 file. Then execute this command. Now this time we will be running it on query installed and 0.1. We have done that. So approve. Let's approve this on or sorry. Okay, execute this command now. Okay, very good. So this is also valid. I'll just wait everyone to confirm me that you're able to do this. Okay, great. Okay, so now that we have approved it, next step is going to be we need to commit our chain code. Okay, so the step 10, chain code. Okay, so now what we're going to do, chain code approve from organization org1. Okay, so we're going to execute this. We'll commit it on the chain code 1. Okay, so what we will do now, we will check the commit readiness. Okay, so check the commit readiness. So execute this command. Similarly, check the same thing on the source organization 2 as well. Okay, it says approvals are ready. Okay, arg1 is also true, and from arg2 is also true. Okay, very good. Now we will commit this file. So before we commit this file, let's create another configuration file. The configuration file, we will add configuration about our channel. Okay, so now create a new file as this one. Okay, create a new file under test network only. That's been done, right? Why are you doing that again? Now we execute that 470 file and don't execute. I mean, create a new file. Oh, that's how doing it. Okay, I'll wait. Yeah. Now create a new file under test. And now you see the read that 475 line. Create a new file under test network and give the file name as lifecycle setup channel commit sh. Okay, once you created that file, I'll tell you what content you need to put it there. Similar to the variables what we have created before. Now let's add these variables. Add below content. Okay, so add the below content to a particular file. And like we did before, just take a look at all the variables and what configurations we are doing it there. Okay, once you added that, now let's source that file. Okay, so when you guys executed the command 463 and 466, did you replace that package ID, the car showroom ID? Go to the right side. You should have line number 463. Yeah, there's a package ID, right? This package ID should have been yours. So wherever you see package ID, that should have been yours. You executed the wrong one now. Okay, so in that case, see if you try to do something now in between, it will throw error. So you'll have to redo the steps. Wait a second, let me make it more better actually. Instead of that, I'll create one variable. We'll assign the value to that variable only once, and just give me a second. Let me update that code. It'll be easy for you. I'm editing all the files with the package ID. I'm adding it there. Just wait. Should be okay. I'll tell you what changes I made. Scroll up. Okay, now wait, no, not too much. Slowly. Okay, scroll down little bit. Okay, scroll down. Okay, scroll down. Okay, scroll down. Yeah, stop there. Yeah. So now if you see at the line 436, 437. Okay, so what I've done here is whenever you execute 434, that query installed, that will print you your package ID. And then you execute 437 line, but replace this value with your package ID. I'm setting it up a variable like a package ID. And after that, you can just execute every other command. If you see line 442 and keep on reading that line, you see that the package ID, instead of hard coding that, I'm actually reading that value from that $package ID. Okay, similarly, wherever package ID is required, I'm reading the package ID from that. Yeah. So now what I want you guys to try doing here is now re-execute all the steps from beginning. But this time, just make sure when you're creating the package ID, this package ID, you replace this and then you continue with all the access. And make sure that if anything fails section is there, right, that you don't execute it now. Maybe I'll move this to a top somewhere, okay? So that if anything fails, it can go there. If anything fails, whatever I've given, I'll remove that. Yeah, okay. So I'll remove that. I'll go to the top of the section. Then I'll put that command. All right. Okay, great. So now what you do, you continue, from where you have to do redo things is from you created all the files. You don't need to create those files, okay? That whatever sh file we have created, you don't need to create that. But what you need to do is add below content. No, yeah. From 391 line, continue to execute all the commands. 391 command. Yeah, from there repeat all the steps. But as I mentioned, wherever it says create this .sh file, don't do that because you already created it. Only execute that source you execute, then you execute the command. But don't create the file, add the content. Yeah, redo everything from beginning. Yeah. Okay, so now we've created this, and the next step, what we wanted to do is let's commit this. Okay. Yeah. So execute this command, below command, which will commit our chain code to the channel. All right, that worked for you. Very good. And now what we are going to do here is let's just execute the query committed. Do this on organization 1. So that first source this file and then execute this. Just check whether this particular chain code has been committed on the channel, my sample channel. Okay, very good. Okay, so it's fine now. Now the next step is let's we will be invoking our first chain code. Okay, so we have done with all the steps now. So we are able to commit it. We are able to basically package, install, approve, committing is done. Final step, we're going to access the chain code. Okay, execute the first command. And this command, wait, I'll tell you what it's doing. So here it's telling pair chain code invoke localhost 5050, that's order node. And then they order example.com and TLS and go to the right. And yeah, so now here we are telling connect to this particular channel, sample channel, to this particular smart contract, which is car showroom. Go to the right, which is running on 7051. That's your peer address 1, peer 0, and keep on going. And the next one is a 9051. That's your org 2. Okay, keep scrolling to the right. Okay. Now at the last, if you see here, what we are doing here is at the last, yeah. If you remember, when we wrote our chain code, we have written that init ledger functionality, right? So this init ledger functionality will insert first car in our chain code. Okay. So execute this. I hope you should not get any error. Can you execute 506 command? Okay, amazing, amazing. Okay, so whatever happened with you, it's completely done. Go back to your output now. I'll explain you what you did now. So if you see here, the previous command, not that command. Now come to that previous command here. Yeah. Oh yeah, that's it. That's it. No, you're there. Okay, stay there. So in this one, if you clearly notice, you are actually executing a smart contract function called as a add new car. And in the add new car, you're inserting a new car with the car ID is 2, car model is Ford, owner is John, and the value is 1000. It is successful. Now scroll down, go to the bottom. Yeah. Now this time, amazing. So when you're querying car by ID 2, you're actually getting the result. The car 2 ID is getting it. Lovely. Okay, so this is how it should work for all of you.
Okay. So if you already have a created instance, you can at any point of time just select that and start the instance. So I hope we are aware at what point of time I have logged in, right? Like what is this console of AWS? I hope everybody is aware about that. If you're not, please let me know. I'll explain how to reach this as well. So see, any of these things you can use. That's not the issue. So you can use Oracle VM VirtualBox. You can use any remote system, or if you can also use a Ubuntu subsystem, like the way I have over here in my machine. This is a Ubuntu subsystem. Okay, you can even use this. You can even use a shared hosting on web servers, like we have a lot of companies that provide shared hosting, right? Like Linode, HostGator, GoDaddy. Or you can use a system with an Ubuntu operating system. But the most preferred way would be using a AWS EC2 instance. Okay, so this is the preferred way. It's production grade, and this is what we will be doing. But it's not that this is the only way. Let me clear that. Okay, it's not that this is the only way. Definitely, you can use any of these method, or you can even prefer to do by having a Ubuntu subsystem in your machine. Like either you have a Ubuntu subsystem in case you are working primarily on Windows, then you must have a Ubuntu subsystem, or you can directly have a Ubuntu machine only. Then in that case, you don't need a subsystem. This can be preferred. Definitely, it can be preferred, but it's not production grade, obviously. Creating a AWS EC2 instance would help, not only help you to learn things like for a learning perspective, but it will also make you production grade application builder, because whatever we will be doing on Ubuntu AWS EC2 instance would be production grade. That's what you do for production based applications as well. Make sense?
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
So anybody having any questions like how do we set up AWS? If that is a question, please let me know. I'll explain that. Otherwise, I am assuming that all of you are familiar how I have reached over here. Perfect. So let's have a quick introduction about AWS first. So over here, see, we have something called as Amazon managed blockchain as well. So I want all of you to be very familiar with this. So see, there are different services that are provided by AWS. There are different services that are provided by AWS. These are some of the most used services. Okay, these are some of the most used service. Not this one. Obviously, this is only for blockchain, but others like Lambda, Route 53, and then something what is not added over here is S3 bucket. So Lambda, Route 53, like over here we have EC2 instance, we have Lambda, and for containers we have S3 bucket. Elastic Container Service. So these are something that are very widely used when it comes to AWS, and alongside, see, these many different things are there, and within each of everything there are certain services that are provided within by AWS. So obviously we cannot go through everything, but something that is of our important is when we go to blockchain. So now Amazon has launched their own service known as AMB, Amazon Managed Blockchain. What is this Amazon managed blockchain? With the help of Amazon managed blockchain, you can go ahead and create your own applications of blockchain on Amazon itself. And this will this will help you to focus only on the logic of the smart contract. Like I can assume that you all have already gone through smart contract, understand what is smart contract, the business logic and everything, right? So you understand that like how anybody who would like to differentiate Hyperledger with Ethereum? Anybody who would like to do that? How do you differentiate Hyperledger with Ethereum when it comes to development? Not like public, this is public blockchain, that's private. No, not like that. What is the core differentiator when it comes to developing an application between Ethereum and Hyperledger? Anybody who's aware about that? Right. So yes, so a key differentiator would be that in Ethereum we just focus on the business logic. In Ethereum we just focus on developing the smart contract. We don't actually spend a lot of time spending a lot of time on how do we set up the network, what would be the consensus algorithm, how many nodes would be there, how many miners would be there. All these things is not something that we bother about, right? And this is quite vice versa in in case of Hyperledger. In case of Hyperledger, you have to take care of each and everything, right? What machine do you want to set up? How many nodes do you want? How many ordering service do you want? How many committing peer? How many leader peer? How many endorsing peer? Who will hold the chain code? So all these things adds up to the complexity, but at the same point of time, it also makes it very much what do you say, readily available. It also makes it very much flexible. You can customize things as per your need in Hyperledger. Unlike Ethereum, in Ethereum, you cannot customize anything other than the smart contract logic. Okay, you cannot choose to decide who will be able to see your transaction. You cannot choose to decide who will verify your transaction or authenticate or validate your transaction. You cannot choose to decide who can store your data. Whereas in Hyperledger, you can pretty much define and decide all these things. So that is the reason most of the private corporate companies, when it comes to setting up a private blockchain network, they prefer Hyperledger. Now again, so over here Amazon have came up with a new service which offer you to create a blockchain, wherein again they help you with all the basic setup of amenities. You don't actually have to do a lot of customization. So it's like a plug and play service. You just select what I'm selecting right now, you just select that, and with the help of that you can easily set up a private or a public blockchain setup within no time, like within hardly 5 to 7 minutes. Okay, so this is something, this is not a part of the course, but this is just I'm making all of you guys aware that there is a service something like that that exists with Amazon, and you can choose to use this as well. Okay, so it see what's it's saying, it can help you with easily creating and managing the scalable blockchain network. Okay, so you can go through the pricings and everything. Obviously there's a paid version, not a free version, and it helps you to very easily set up a network. So public blockchain is something that you guys are already aware. So I'll just click on private blockchain, and over here as of now they're just supporting Hyperledger as of now. 2.2 has been added as well. So this is the latest version of Hyperledger Fabric as of now. So network edition is starter or standard, whatever you want to select, you can select. You can give a name to your network, whatever name you want to give, like my network or any name of the organization that you want to prefer. You can give that name over here. Description, you can write a small description about your network. what would be, what it is all about, and everything, whatever you want to put it up over here. Voting policy, you can decide that who can vote and how they can vote. So greater than or greater than equal to, then you can vary the percentage as well, and what would be the proposal duration. Okay, so everything can be customized over here. So we will move ahead, although we'll not set it up, but yeah, we'll try to see what are different things that are there. Now, it gives you an option to set up the member. So all the member, those whom you want to add over here, they must be having a EC2 instance account ID basically. So you can either search them by the name of the organization, or howsoever you want, you can search them. Description, you can put up the description again for them, for those specific members over here. And then you want to decide who would be the certificate authority. I hope you guys are already aware about the concept of certificate authority, right? So who would be the MSP basically, membership service provider? So you can create an admin username and admin password, whatever you want. And then accordingly, you can enable the certificate authority logs, which will help you to get to know what exactly are the course of actions that are being performed by them. Okay, so this is just like everything is predefined and readily available for you. You just have to fill it up like the way you just fill up a form in like that. And then okay, so yeah, so this is the second step, and this is the pretty much the last step. After that, on top, you can see over here. So step number 3 is just to review and create. So in step number 3, you will just review what you have set up over here and here, and then you will just go ahead and create it. Once you create that, automatically all the prerequisites, all the Docker images, all the images that are required for the Hyperledger Fabric setup would be initiated and installed in a EC2 instance by the Amazon itself. So this is the advantage that you get by selecting Amazon Managed Service of blockchain. Okay. So this is the advantage that you get, yeah, as I explained. But again, this is, to be very honest, it is not something that has been adopted by a lot of organizations till now. I'm not sure why exactly is that. Maybe because of pricing. The pricing is high, or maybe not because of the flexible behavior. They are not providing a lot of flexibility. Still, they are trying to constrain certain things like the consensus. You cannot vary the consensus over here. You'll have to move with the raft consensus that's offered in Hyperledger Fabric. So that's another thing that might be another reason. But yeah, whatever it is. So that is how it is. So this was Amazon's own service of providing a blockchain setup network. Now, what we are going forward as of now is you'll go in compute section. Okay, you'll go in compute section. Under compute section, you'll find something known as EC2. So see, firstly, what I did, once you log into your console, make sure that you select Asia Pacific Mumbai. This is very important. Make sure that you select Asia Pacific Mumbai. Okay, this is very, very important. Don't forget this. Then after that, go in services, although you'll be able to see it over here as well. But in case this is something that is customized as per user requirement, so you might not see over here. So I'm telling you, you go in services, you go in compute. Under compute, you go in EC2. Once you go in EC2, then like this, you'll be able to see. So as of now, everything would be 0 for you. For me, instances are 2, key pairs are 6, security group are 6, volumes are 2. But you can ignore. For you, everything would be 0. Where you have to go is in instances. Don't go in instances running. Probably for you, it would be there, but it would be 0. So don't go over here. You go in instances. The reason why I'm telling not to go in instances running is when you go in instances running, there will be a filter added known as running. There's a filter added known as running. So that's the reason I don't have anything. If you're coming over here, then just cross this off, close it, and then you'll be able to, again, you'll come to instances. Now over here, you won't see anything because you haven't created any instance. We'll go ahead and create a new instance. So just click on launch instance, give a name, whatever name you want to give, you can give. Now, please make sure you follow all these things very carefully. Okay. So don't miss out any of these things. So first, when you put up the name, okay, after that, if you want, you can put up some additional tag in case if you want to, like differentiate or remember it with some keyword or anything, you can use some additional tags as well. Then it comes about selecting the operating system. Okay, so see what this EC2 instance is basically a machine. Okay, so when we talk about EC2 instance, what exactly it is? It's like Amazon have set up their huge servers. Amazon have set up their huge servers at some places. And what are those places? The one that we just selected, you see, Mumbai. So these are different places where Amazon have their servers. And this is the identity, AP South is one. This is the identity of these servers. So now in this server, what I'm doing is I'm just requesting for a small computational power. I'm requesting Amazon to dedicate that small computational power for my users. And because I'm using that small computational power of this whole big server, I'll be paying some rent for that according to whatever services I use and I consume. Whatever services I use and I consume, accordingly for that, I'll be paying. Make sense to all of you? So this is what is EC2 instance. Okay. So when we talk about EC2, what it is, it's basically a small portion on the server that we are renting out from Amazon, using it for our own purpose and paying the rent accordingly. What exactly is this? It's just like a system. It's just like a computer. It will have some RAM, it will have some ROM, it will have an operating system, just like your system has. That's what we are configuring right now. So now we are selecting the operating system. Make sure you select Ubuntu. Under Ubuntu, you'll have multiple options. Make sure don't select 20. I'll prefer 18.04 or maybe 20.04, whatever it is, but at least not 22. Yeah, go with 18.04 and make sure whatever you are selecting, it should be free tier eligible. Okay, whatever you're selecting, it should be free tier eligible. So see what I've selected right now is free tier eligible. And then architecture, 64 bits of architecture is fine. Next, we talk about instance type. So don't select T2 micro. Okay. For you, you might get T2 small as free tier. I'm not getting it because maybe I've already created it. I'm not sure. So prefer T2 small. So just select T2 small. And then you'll be creating a key pair login. Okay. So how exactly do you create a key pair login is basically with the help of, if you have already created, well and good. If you have not created, just click on create a new pair. Over here, make sure you select ppk file. Just enter a key pair name. So it would be downloaded over here. And then this is your network setup ID. So you can just make sure that you select allow SSH traffic from anywhere. And if in case you want to restrict it, you can restrict it. But I would not prefer that. It might create some issues. So just let it be from anywhere. And 8 GB is enough for now. You don't need to customize it. And I think, yeah, rest everything is fine. So under advanced setting, you don't have to change anything. Make sure this is only for advanced customization purpose, which we don't need to do at this point of time. This is just a summary. So we are trying to create a Ubuntu 20.04 system with the MD64 processor. T2 small is the type of instance that we are creating, and it's of 8 GB. That's more than enough. And if you want, you can increase this. But again, I would not suggest that. But in case if you want to increase the storage, you can do that, but it's not needed, to be honest. After that, you can just click on launch instance. So go on view all instance. So you can refresh it, and now as you can see, it is in pending state. It might take some time. Yeah. So now the instance is running, and this is the dedicated IP that has been assigned to you. So now what you need to do is you'll have to connect to this server to check if you are able to successfully connect to this server or not. How do you connect to the server? Anybody has any idea? How do you connect to these servers? Okay, so for that you can also use a tool that is known as Putty. So in Putty, you can. So how many of you know what is Putty and how to get it? Anybody has ever used Putty? So see, basically there are two ways to connect to EC2 instance of Ubuntu. We have Putty, that is the SSH connection, and we have WinSCP FileZilla for directories and file folder update. So the way how to get Putty is you go to this site, puttygen.com, and you download Putty. Simple, okay? So whatever you are using right now, as per that, you can just select. So over here, this is the MSI installer file. Accordingly, you can just select that and download it. Alongside, I'll also recommend to download WinSCP as well. So WinSCP is basically used for transferring the data, transferring the files and folders from your local system to your remote system very easily. Although you can do that with SSH commands as well, but then it would be quite complicated. So that's the reason I would suggest to download WinSCP as well. So these are the two tools that you must have in case if you want to communicate to your external server or your EC2 instance. Okay. Once you install Putty, then you would be able to land over here. You'll get a what do you say? You'll get a thing like this. Now over here, you just have to use your IP. Just paste your IP address over here. Make sure you select the connection type as SSH, and then go in SSH, go in auth. Under auth, you can select the PPK file that you have. Okay, so see, this is the PEM file that I just, private putty key file that I just created. So PPK file, just open it. And if you select PEM, then you'll have to convert that to PPK. Okay, so it's better that when you are generating the key value pair, generate PPK file only. Okay, so select open and go back to session. Now you can just type open. You can log in as root because that's what you selected as username. By default, the username is root. Oh, okay, sorry. It's Ubuntu actually. So I'll have to re-log in. So just when you are creating the instance, just see what you have selected. Is it Ubuntu or root? By default, it would be Ubuntu. So just hit enter. Okay, maybe I didn't select. Go back to SSH again. Auth. Select the browser file as private putty key file. Go back to sessions. Type the IP. Open. Login as. So now you can see I have successfully logged in. Okay. So authentication was done with my private key file, that is new batch 7th August. Okay, and I have successfully logged in. And if I see what's available over here, nothing is available over here. So now I have successfully logged into the terminal of my EC2 instance. Okay. Okay, perfect, working good. So now what is the next step? Can anybody tell? Now that we have successfully created a EC2 instance on Amazon and we have successfully logged in into our application with the help of a putty key file using putty as the software. Okay, another thing. Let me show that as well. So that was FileZilla. For this, you will be needing that PEM file. Remember, we created a PEM file as well. Anyways, though this is of not of any use right now. Maybe I'll guide you with this thing at later point of time. But this is where you would be needing the PEM file. Okay, leave this for now. So anybody now, what is the next step? Is anybody aware about that? What is the next step now? Now we have set up a EC2 instance. We are done with all the hardware configuration is completed. Now the next step moving forward is to do the software configuration, like all the prerequisites of the softwares that are needed in order to create a Hyperledger Fabric application. We will be going ahead and installing the prerequisites. Okay, one more thing, guys. Are you aware about how do we connect to the remote session using our VS Code? So what IDE were you using for development? Okay, so are you guys aware about how do we connect to our remote session or remote EC2 instance using our VS Code, which is available on our local system? Okay, if that is clear, then well and good. So yeah, good that it is clear. Now that we'll move ahead and see how about the installing the prerequisites. There are certain prerequisites that are required for Hyperledger Fabric 2.0. So Hyperledger Fabric 2.0 component requires certain softwares to run. For instance, if you want to develop the chain code, you need to have a Go language installed on your machine. Therefore, Hyperledger Fabric has following list of components that needs to be installed. So these are the things that we need to install. So we need curl, we need Docker, we need Docker Compose, we need Go programming language, we need Node.js, we need NPM, and we need Python. So most of the things that you'll see over here are with respect to programming only, like curl. So curl is basically used for different types of read-write operations with respect to APIs. Node.js is again a JavaScript enabled programming language or only enabled for server-side programming. That's basically a browser-based programming language. NPM is for managing different versions of Node. Okay, so let's suppose in your application, one module of your application requires a Node.js version of 8. Another module in the same application requires a Node.js version of 12 or 11. So how will you manage that? Because as a part of a single machine, you might just have one single version of Node.js, right? But then one part of your program needs it to be having a different version and the another part of the program needs it to be having a different version. So for that we have npm, that is Node Package Manager. So there are different, npm can help you to handle and manage different versions of Node program. Python is again a programming language. Okay, Python is again a programming language only. Yeah, so we can say that, basically to remove the hardware dependency, okay, from the applications, that is where Docker comes into picture. So Docker is basically one of the containerizing tool or containerizing way to containerize the application. So when I say containerize the application, it pretty much looks like the way it sounds. Okay, so it's like, let's suppose this is your PC having some other computational configuration, maybe like i7 processor and some GBs of RAM, some GBs of ROM, some different architecture of RAM and everything. And then this is some other application, some other computer having completely different architecture and computational power as compared to yours. Now, if you built or if you developed an application in your system, if you developed an application on your system, how sure you are that if you move this application from this system to this system, it will run the way it was running fine in your system. So this is not at all, no developer can provide this assurity that once our code is moved to other application having other type of computational architecture, then the code will function the exact same way how it was functioning in my application in my system. No developer can assure you that. Okay, the reason is there are a lot of software and hardware goes hand by hand. Okay, so software and hardware are not completely separated from each other. No, they are integrated part when it comes to an application development and the application use. So they go hand by hand. So this is where Docker comes into picture. So Docker along with some hardware dependency, will containerize your application, okay, and will put it on a server that is not dependent on the hardware dependencies. So it will resolve all the hardware dependencies of your application so that your application is fit to run on any machine that you take it to. Now that you containerize this application, it can go on any machine where you install this image. So basically it would be called as an image of Docker, and you'll just have to download this image and set up as per the guided policies. There will be a README file within that Docker container. You'll just have to follow those commands, set it up, and it would work the exact same way how it was functioning in your local system. Okay, so the reason what led to creation of Docker or development of Docker is at earlier point of time, we were following a monolithic architecture of developing applications. But now we are following a microservices architecture of developing applications. So earlier, one single application used to be very huge and very big, which was very difficult to debug, understand, and make some changes. But now we have a big application broken down into smaller pieces that are known as microservice. So these microservices may be developed by completely different teams, okay, but can be put up all together to behave as a single application. Okay, so this is just a quick overview about Docker and all, although nothing to do with the blockchain application, but yeah, just to give a quick overview about what is Docker, why do we need Docker, and what problem or what issues does Docker resolve. Is that clear to all of you now? Okay, hope that makes sense to all of you. Any questions, any doubts from anybody? Accordingly, you will have to configure it also. When you are building up the image for the application, you will have to accordingly configure it, all those things. Then only the other person who is using that image will be able to do that. So these are pretty much different types of dependencies that we need in order to set up a Hyperledger Fabric application. Okay.
Just a quick info, guys. Intellipaat provides blockchain certification training mentored by industry experts, the course link of which is given in the description below.